Hello, everybody. This is Bradley King. It is 10 o'clock in the morning, Denver time, noon Eastern. We're just going to give one more minute to allow a few additional individuals who might be coming in, and then we'll get started with our day's events. Thank you, and we'll be starting in just a minute. Thank you. All right, everybody. It is 10:01 on my clock here in Denver, and I would like to welcome everybody to our second day of the Silica in the Oilfield Summit 2.0. I hope everyone enjoyed the content that we heard yesterday. I thought we had a really great selection of speakers, heard some great information, and I'm looking forward to hearing all of the content that we have lined up for you today. I hope everybody had a great evening, and I'm looking forward to being with you all for the rest of the 4 hours today. I would like to go through this disclaimer as well, similarly to yesterday, but I thought it bears repeating that the findings and conclusions in these presentations are those of the authors and do not necessarily represent the official position of the Centers for Disease Control and Prevention, CDC, the National Institute for Occupational Safety and Health, NIOSH, and the NORA Oil and Gas Extraction Sector Council. Mention of any company or product does not constitute endorsement by CDC, NIOSH, or the NORA Oil and Gas Sector Council. A few housekeeping tips and pointers. These are similar to what we heard yesterday. All participants will be kept on mute throughout the duration of the presentation. And as you saw yesterday, there is a Q&A chat box in the control panel. So if you have any questions that you would like the speaker to potentially address at the end of their presentation, please use the Q&A box. And then for other comments, or if you have issues, technical issues, things like that, you're more than welcome to use the chat box function for that. This webinar is being recorded, and I also wanted to remind everybody that there will be a survey at the end of the second day of the summit, so that's the end of today's summit. We ask you that you either take a minute to complete it at that time, or we will be sending an email out with a link to that evaluation as well. We have gotten a lot of questions over the course of the past day in regards to making available PDFs of all of the different presenters' content that they showed. And yes, we are going to make that available. I think I have copies of almost all of the presenters' PDFs at this point. So we'll be putting those together and putting those online, and we will be sending a link out to all of the attendees that would be able to then, you could click that link and take you to the website where we will be housing all of those PDFs, and then you can download all of the PDFs or the ones that particularly interest you for your own keeping. We will also be putting a recording per the permission of all of the individuals who are presenting onto the YouTube channel of the Center for Health, Work, and Environment. So it will probably take at least a few days for us to put those PDFs and that YouTube content online. So what we will be doing at the end of the session, or at the end of the event, either today or tomorrow, we will be sending out an email to all of the attendees confirming that your attendance. So you will be able to then use that certificate or confirmation of attendance to be able to submit to your organization if you need continuing education credits or units for your certifications. So be on the lookout for that email within the next day or two for your kind of records. And then, like I said, we'll follow up with that with another email sometime in the next week or so that will, once we have everything online for you to be able to download. So that, I think, answers most of the questions that have been coming in. let's go ahead and take a look at the agenda for what we have planned today. Similarly to yesterday, we will be taking these kind of in chunks. So we'll be hearing from 3 individuals in our first session today, Mr. Tom Thorne from Arkham Armaz, Brian Dorfman from PropX, and then I'll be giving a presentation after the 2 of them. And then we'll take our first break at 1:15 Eastern time, 11:15 Mountain time. So without further ado, I'm going to stop sharing my screen, and I will invite Tom to share his screen, and then we'll get started. So while he's starting that process, I will go ahead and give an introduction to Tom. Tom Thorne, pardon me, hold on. Tom Thorne is currently Commercial Manager, Energy Division at Arkham Armaz, a global market leader in the provision of specialty chemicals for the mining, fertilizer, asphalt, and oil and gas industries. Tom has more than 30 years of industrial chemical experience in a variety of roles, including sales management, business development management, and chemical application management. He received his Bachelor of Science degree in Petroleum and Natural Gas Engineering from Penn State University and currently resides in Pittsburgh, Pennsylvania. So Tom, the floor is yours.
Thank you, Bradley. Yes, I am Tom Thorne, Commercial Manager with Arkham Armaz for their North America Energy Division. If you're not familiar with Arkham, we're a French-owned specialty chemical company with operations worldwide. Our surfactants group, of which I'm a part of, is based in Mulberry, Florida, which Mulberry is about an hour south of Orlando. Bradley mentioned yesterday, we heard some great presentations about the dangers and health hazards of respirable silica dust. And we heard some of the ways you can mitigate that dust. So for the next 20 minutes, give or take, depending how fast I talk, I'm going to talk about a method of mitigating the silica dust before the sand ever arrives at the frac site. 3 topics of discussion for my presentation. I'll start off with a brief list of criteria to consider when you're choosing an engineering control option. And we know there's multiple options out there on the market. And then I'm going to talk about the benefits of our proppant coating to help meet the silica dust PELs. And finally, I'll wrap up with some of the sand characteristics, the impact those characteristics have on the type of proppant we choose and how it performs. So let's get started with topic 1, criteria to consider to evaluate the different options. Now, these by far are not all of the things to consider, but I think they're my top 7. Number 1, does the engineering control reduce respirable crystalline silica dust to below the PEL? And frankly, that's why we're here today. That's the purpose of this seminar, is to talk about achieving below PEL crystalline dust. But almost as importantly, you should consider and ask yourself, will the engineering control I choose reduce the silica dust to below the action level as well? Because if you can get below the action level and you have data to prove that, you're pretty much done. You don't have to invest in any additional monitoring costs. Your people are safe. That's our target at Arkham, is to get below the action level. Should also ask if the engineering control occupies a lot of real estate on the operations site. Frac sites are tight. There's not a lot of extra space. So that may be a real concern for some operators. Is there room for the control I'm considering? Should also ask if the engineering control provides continuous protection across the hydraulic fracturing supply chain, or is it only effective at the point of application? That could also be important. Does the engineering control require equipment with ongoing maintenance needs? Maintenance needs equates to maintenance costs in many cases. So that's something you should consider if it's a mechanical device. Does the engineering control require single or multiple setups per application as you move around different well sites? And lastly, on my list is, does the engineering control work with your unique sand or a combination of sands you may be using for the frac job? I'm going to move on to the benefits of a proppant coating, which we manufacture, to help meet silica dust permissible exposure limits. What's really nice about a coated sand is that the silica dust reduction is part of the sand. It's built into the sand. Reduction in silica dust generation of up to 99% throughout the supply chain can be achieved. There is no on-site footprint with coated sand. All of that process is done upstream before the sand ever arrives at the frac site. So we don't take up any real estate at all at the frac site. Our products are environmentally friendly. They're made from naturally occurring biodegradable and biorenewable substances that are used in everyday food, nutritional, and personal care products. They're non-toxic, they're non-irritating, and they're odorless. And most importantly, they're 100% USDA certified bio-based products under the government's bio-preferred program. These are very green, safe substances. This is the label you'll see often in our literature, indicating that we meet the bio-preferred program. Our products are frac fluid compatible. We worked very closely with a major pressure pumper many years ago to make sure that our chemistry didn't have an adverse effect downhole, didn't affect production or any of the formations. They do not. There's no drying or curing time required once the chemicals applied to the sand. It's immediate. So we don't slow down, for example, at a sand mine, if we're applying it there, we don't slow down the load out process at all. And probably most importantly, the coated sand lowers attrition rates of the proppant. And really that's how this chemistry works. So we apply a microscopic coating on the sand, which controls dust, lowers fines generation by reducing attrition when the proppant is transferred. Every time that sand is moved, you get little pieces, you get attrition, and we reduce that dramatically. It's a little kind of picture to give you an idea. So an uncoated sand, you're moving it from a transload to a truck, it collides. And when it collides, you get little pieces broken off. That's the fines. That's the crystalline dust that we're talking about. With coated sand, you have the same phenomena. You're moving the sand, they collide, but there's no dust released. The particles just kind of, they go across each other, but they don't break apart. And that's really how our chemistry works. I've heard from some folks, I think I heard this in one of our last meetings, as much as 10% of the sand is lost through attrition. Well, that's money out the window. So we can reduce that dramatically. The chemistry is stable, very long lasting. It can be transferred multiple times through trucks, through transloads, and that chemistry will stay with the sand. Once applied, all points along the supply chain are protected from silica dust. So the sand leaves the mine, it goes to a transload, the dust is gone there, it's protected all the way to the well site, all the way to the well head. So everybody benefits from the coated sand. The last topic of discussion is one that we've learned over the years through trial and error, that all sand's not alike. I don't think that's a surprise to anybody, but how sands react to chemistries and different coating rates varies. So we've done a lot of work on that phenomenon. There's really four things that we look at, primary things we look at when we're evaluating sands for coating. The first thing is the sand shape. And sands can basically be categorized as either spherical or angular or subangular. Spherical sands, as the picture on the left, that's typical of northern white. They're very round, they're smooth on the edges. Angular sands, such as the picture on the right, is what you find in in-basin Texas sands oftentimes. This is a graph of data that we generate this in our Mulberry lab. We took the same grade of sand from 3 different mines, and we evaluated them for dust production. We basically churn up the sand, we measure the dust that's emitted, trying to simulate pneumatic unloading of a truck. And as you can see, sand mine A, which was angular, generated a lot more dust than sand mine B and C, which were spherical in nature. Rounder proppants in general display lower levels of respirable crystalline silica dust, while angular proppants sometimes require a different formulation, which we have developed several, or they require perhaps a higher application rate than the spherical. Not always, but sometimes. Second thing that we look at, very important to how coatings work, is the content of fines in the sand. We know those fluctuate. You can have as low as 0.1% fines in a sand and as much as 10% or more. Generally speaking, a lower percentage of fines will require lower coating application rates. Again, here's some data from our lab where we took 2 different sand mines, same grade of sand, 7140, but with different fine contents. So sand mine A on the left had a sand fine content of less than 0.2%. Sand mine B was almost 0.75%. And you can see the dust that was emitted when we did our test greatly higher with sand mine B. More fines typically equate to more dust. Sand surface area is another characteristic that we really look at hard. It can be impacted by either the fines, of course, and the composition of the sand itself. The higher the surface area, the higher the coating rate is typically needed to get down below the PEL. Now, with sand composition, which is the 4th category of characteristic we look at, really depends on how the mine is operated. You get different quality of sands, as you've seen even from some of the charts I just shared with you. Has a lot to do with how the mine is operated and how it cleans the sand. That's probably the biggest impact. So sand contaminants such as clay, they've got a high surface area. If they're not washed out, if they're not cleaned out at the mine, they'll stay with the sand and they'll tend to absorb some of the chemistry, making you need more. It doesn't necessarily mean it won't work, it just might need more chemistry. So cleaning the sand is really important. We look at all these things. We run multiple tests, some of them on those charts, and we optimize the coating, the right coating, and the application rate before we even go to the customer with a recommendation. We developed SandTech, and that's our product name, silica dust control coatings with all of these sand characteristics in mind. SandTech coatings are customized to work with silica sands of all kinds of characteristics, northern whites and Texas browns and everything in between, to ensure optimal silica dust control performance. Field trials have proven that SandTech is effective in achieving dust reduction targets below PEL and below the action level, which again is our ultimate goal. Dust reduction across the entire hydraulic fracturing supply chain can be achieved with no negative impact on sand handling and no downhole well performance impact. I will add, because I always get asked this question, well, does it improve downhole performance? It does not. These products are water soluble. They hit the frac fluid and they just become part of it, but they do not enhance anything downhole. They don't hurt anything, but they don't enhance. These are some photos that I actually took. This is from a sand mine in the Eagle Ford. The picture on the left, obviously, is untreated sand. This is it's coming off the conveyor into the warehouse. We then started to apply the chemistry. And the picture on the right, of course, is the same sand after being treated. I also have a short video. It's not very long at all. It gives you another perspective of untreated, which is the top picture, versus treated. Get it to work. Where's my arrow? There it is. All righty. So in summary, June 23rd of this year, again, this is why we're here, OSHA will begin enforcing requirements for engineering controls for hydraulic fracturing operations in the oil and gas industry. And June 23rd is fast approaching. RMAS has developed and patented several liquid chemicals that, when applied to frac sand, can reduce silica dust by up to 99%. Our chemistries require no frac site equipment. They work on all frac sand sizes and are compatible with a wide variety of frac fluids. The chemistry does not slow down fracturing operations or negatively impact well performance. And lastly, these products, as I mentioned earlier, are non-toxic, non-irritating, odorless, and biorenewable. Thank you so much. I think we have some Q&A time set aside.
Yeah, great. Thank you, Tom. So we do have a few questions that have come in. I have one myself. You had mentioned that some field trials have shown that these are able to get exposures below the PEL and even the action level. I guess I'm interested in learning a little bit more about those field trials. Were those trials exposure assessments that you guys did, or did you work with a client who was trialing it out? And what is the extent of the data that you have in regards to some of those field trials showing its effectiveness as a control? I think that kind of connects with one of the questions that came in. Does the sand absolutely prevent dust and fines? Could you comment? Yeah, could you comment about that?
That's a question that's often asked. So we have on staff several industrial hygienists who will go out as part of our offering and make those measurements. And we did that on the trials. Typically, the customer did the same. Most of our customers, I'd say probably all of them, unless you have it in writing, aren't willing to share that data. That's all internal to them. We can certainly share our data. It would have to be, we couldn't identify the customer, of course, but we have that data and could share that, certainly.
Yeah, no, that would be great. I would love to have a further conversation with you in regards to that. I know that there's a lot of interest in regards to, how does it impact, a variety of different worker titles, who might be on the site. And so, getting a sense of what that data is showing, and is it covering everybody that we need it to cover? And, we would love to explore that with you. So if that's, a possibility to take a look at that and maybe making that data more publicly available, I think that would be a great collaboration.
Absolutely. That's easily done.
Great.
Sure. And what we did, we put monitors at different locations, as you referenced. So we had them close to the blender, or where they're offloading, just different locations, and you could definitely see higher and lower quantities of silica. Okay.
We had another question that asks, why do angular sands create more dust?
I think it's just because they're sharper. They're not, when round sand, it's almost like marbles. They just don't break apart as easily. But when they're sharp edges, the angular sand, they typically break apart much easier. It's just that simple.
Okay. How do you evaluate if enough coating is used out on a site?
So before we recommend a coating rate or product, we always ask for samples of the sand. Typically 5-gallon bucket is all we need. And we'll do all those tests in-house in Mulberry, and we'll come up with what we believe is the optimum dosage. Normally we'll start a little bit higher and then come down and optimize that rate. But we just watch the dust that's created and measurements. You have to measure. So that's how we optimize.
Okay. What is the cost associated with the product?
I was waiting for that question. That's the cost is really dependent on the type of sand, because the type of sand will dictate how much coating you need. And of course, the more coating, the higher the price per ton is. In general, I would say $1 a ton, maybe a little less, maybe a little bit more, but that's around what we're seeing right now.
Okay. What's the shelf life of the coated sand? Does it turn to goo when it gets hot?
does not, to my knowledge, there is not an issue at all with shelf life.
Okay.
Very
And what is,
stable products. They're not, it's there's not a reaction chemistry going on, so they're very stable.
great. What is the application method?
Well, we prefer to apply the chemical at a sand mine. Now we actually have a permanent system set up in Wisconsin with a sand mine that you can call, a customer can call, and they turn a switch on and they make coated sand. We have a portable system. It's like a portable pug mill. It fits on the back of a trailer, a tractor trailer, and we can take that anywhere in the US or Canada, and we've done that. So you basically run the sand through, you insert it into the process, and after the sand has been dried and sized, it'll go through our machine, get sprayed, we spray it on, and then it's churned up with the pug mill, and then it comes right out another conveyor right to the warehouse. That's what we did with those pictures that I showed earlier.
Okay. Are there any offsetting health hazards from the coating to workers at the initial mining end or wherever the coating would be applied in the process?
Absolutely not. You could ingest this chemistry and it would not hurt you. I don't recommend it, but it's very safe. There's no issues.
Okay. Can you estimate what % of frac jobs involve coated sands, either with your particular company or another company that also coats frac sand? Kind of giving a sense of how extensively this is actually used.
I don't know that, to be honest. I wish it was used more, quite frankly. I think it's gaining traction, particularly with the new regulations that'll be in effect come June, but I really don't have a good handle on that.
Can the coated sand be lab tested before being implemented in the plant to ensure there's no interference with the flotation process?
Absolutely. The company that we worked with, that's great, and everyone appreciates that, but typically pressure pumpers or whoever the end user is will do their own testing, and we can help facilitate that, no problem.
Okay. Another question that came through the chat: any toxicological data on the coating?
Yes, that would be on our SDS sheet.
Okay.
I don't have it in front of me, but I could certainly provide that. Yeah.
Okay, great. And then there was also a question about where can we find your published peer-reviewed papers that report on the science and efficacy of this product?
Ooh, can I get back to you on that one?
Yeah.
I mean, beside our webpage, I mean, there's a lot of information there.
Right.
But if there's something specific, I do have my email, on the first slide. Anybody could reach out to me and we can get that for you.
Yeah, I think that question just comes back to the need and the interest from industry and from government folks like myself of the science behind how well it really works, the effectiveness of the control, and letting that data speak for itself, in regards to confirming the claims of bringing it down below the PEL, in particular the action level. So like I said, anything that you can do to help get some of that information publicly available, I think would be a real boon for this type of product.
Yes, sir. I will do that.
Yeah. Okay. Let's see. Have you seen resistance to using coated sand, such as concern about supply limitations, and how have you or others overcome it?
We have not. Obviously with the price of crude, will come back up quite nicely, but when the price of crude is down, cost is always considered. So, that's why that question always comes up: how much does it cost? And we've certainly tried to get the cost down, optimize. Now we're part of a very large organization, Arkham. We were just RMAS until a couple of years ago. We have access to larger, broader procurement opportunities. So that's not been an issue. We can provide the product. And you don't use much. It's about a quart per ton, give or take. So we're not talking large volumes.
Okay. Great. I know that there were a couple of additional questions we didn't get a chance to go to. So Tom, if you wanted to look in the Q&A, you might be able to answer those yourselves. But we do need to move on to our next speaker. I just wanted to say thank you very much for an informative presentation. And if you wouldn't mind, I don't think you're sharing your screen anymore.
No.
So we'll go ahead and move on to our next presenter. So let me get that pulled up. Just give me a second here. Let's see here. Our next presenter is Brian Dorfman. Brian actually provided a pre-recorded version of his presentation. So I'm going to be pulling that up in a second. But before I do that, I did want to give an introduction for Mr. Dorfman. Brian Dorfman helped start Propent Express Solutions, known to the industry as PropEx, from the ground up 5 years ago, and now serves as the Vice President of Operations. Brian attended Georgetown University in Washington, D.C. to study finance and accounting, and he has worked in the oil and gas industry for the last 9 years. PropEx is a modular, containerized last-mile frac sand delivery system designed to be safer for employees and drivers, faster for the frac crew, and cleaner for the environment. So Mr. Dorfman is actually live with us. I see you on your camera, Brian. Hello. So Brian, you can either answer questions in the Q&A box as they come up, or we can do the same thing that after the pre-recorded presentation ends. I'm happy to relay those questions to you, and you can answer them at that point in time if that sounds okay with you.
Yeah, that's fine. We can do both. I'll try and answer the questions as they come up, since my presentation is just recorded, and then if we have extra time, we can chat about it further.
Okay, sounds good. So let me start sharing my screen, and then your pre-recorded version should come up. So just give me 1 second here while I find the right window. Okay, there should be video and audio associated with. If anybody is not hearing or seeing it correctly, please let us know in the chat. And we'll start now.
Hello, everyone. Thank you for having me. At PropEx, we're always happy to share with the industry and the regulatory bodies what we in the oil and gas industry do on a day-to-day basis to make the industry.
Hold on a second. It appears to have stopped on my end. Let me try to start it again. My apologies. Sorry about this, guys.
Hello, everyone. Thank you for having me. At PropEx, we're always happy to share with the industry and the regulatory bodies what we in the oil and gas industry do on a day-to-day basis to make the industry a better, safer, cleaner place. I appreciate you guys taking the time out of your busy day, and I hope you gain some value out of what I have to say today. Today, I put together a brief PowerPoint that starts off with an overview of what PropEx is, where we operate, and what we do. Then I'll briefly go over some of the really interesting trends that are happening in the industry, particularly relevant to silica regulation, and where we at PropEx think the industry is headed. After that, I'll touch on the technology we've been working on and pioneering with our partners and clients at Avintiv for the last 3 years. It's funny to think of wet sand as a technology. However, how it affects the supply chain and how it applies here on the HSE front truly has potential to change the industry. I'll do my best to explain how we see wet sand fitting into the oil and gas industry, and then hopefully open it up for questions. Before I get into my slide deck, I want to touch briefly on the importance of energy to our modern lives. I got this slide from a presentation I saw Chris Wright make, and I think it is an important message. Across the globe, people lift themselves out of extreme poverty every day. Since 1990, 1.5 billion people have lifted themselves out of extreme poverty. Low-cost energy is critical to enable this rise in human beings. Everyone has seen the picture on the right. You don't need a show of hands to know we would all rather live in the South where there are lights and reliable energy infrastructure at night. The picture on the left you may have not seen. This is also a natural border, but this one you can see during the day. On the right is the Dominican Republic. It is a thriving industry, tourists, great culture. Almost all of its energy is imported oil and natural gas. On the left is Haiti. Haiti's dominant source of energy is also oil and gas, over 80 to 90%, but still has a meaningful percentage of its population that is still so poor that their primary source of energy is the same as our ancestors, wood, and they have deforested the nation. Something that is very consistent across poor and struggling nations is an enormous footprint on the land from a small number of people. Cheap energy lifts people out of poverty, and we are all proud to be part of a community of people who work to do that the right way. Frac operations and efficiency have come a long way as the shale revolution has matured. On this slide, you see an aerial view of a modern fracturing fleet. There's a reason we do all of these things. Longer equipment life, less disruption to the communities, smaller footprint on location, efficient, safer, more environmentally friendly proppant delivery, to name just a few. As the shale revolution has developed, there are inevitable interactions between the community and the industry. Our industry continues to get more efficient, safer, cleaner, faster. If you're going to disturb someone for 2 months, but you can get that same amount of work done in 3 weeks, you have massively reduced that disturbance. Can we get better? Of course we can. Can we get cleaner, more efficient? Of course we can. At PropX, we spend a lot of time pondering these questions on how not only to make the process safer, but how to reduce our impact to the communities and the land. At the end of the day, we all use oil and gas, and it enables us to live better lives. The problem that we will continue to work towards is how to operate and produce this necessary commodity the right way. A bit about our company. PropX is a last mile equipment provider. We supply equipment that enables companies to overcome the unique logistics and safety challenges that the industry faces. Think of our product similar to how the shipping container revolutionized global trade, on a much smaller scale, of course. It's a modular container specifically designed to store frac sand. It eliminates the noise and dust from legacy pneumatic hauling methods, increases the efficiency of delivery, which allows for frac crews to do more in less time and makes it safer and cleaner to work around the product at the well site. Since our inception, over 150 billion pounds of sand have moved through the nearly 9,000 containers we have on the market. When we started PropX, the most efficient fracturing operation, we consumed about 4 to 5 million pounds of sand in a single day. With PropX, that number recently hit 13.4 million pounds in a day. This goes back to reducing impact on local communities by getting the same amount of work done in less time. We supply our equipment all over the country, in the US and in Argentina, and partner with multiple types of companies that see our product as an opportunity to impact their business positively, from oil and gas companies to frac providers to logistics companies and even mines that produce the product. Silica exposure was one of the primary drivers of change in the last mile space over the last 5 years. That then led to a combination of trends in the industry that have forced continued innovation. It is easy to see the start and end through the pictures on the left and right, but that does not represent all the different dust control developments that have been tried extensively along the way. To name a few: coated proppant to reduce grain-to-grain abrasion, dozens of filtration and vacuum systems installed all over the frac site, container delivery and storage, controlled cabins, administration controls to keep employees out of the areas of exposure, gravity feed discharge, elimination of pneumatic blowing of sand from truck storage to silo storage, and even trying to figure out a way to keep the sand wet during delivery. After all, why do we dry this stuff anyway? We just get it wet again at the well site anyhow. A couple of notable trends happening in the industry. All of these trends are positive and show the continued innovation of the industry processes. The three charts show how profound the increase in frac sand demand at the well site has been over the last few years. On the left is a chart showing pounds of sand per lateral foot of wellbore, a near 100% increase since 2014. The middle chart shows average proppant pumped per well, a 200% increase in proppant pumped. When you combine more proppant per foot and more proppant per well with increased frac crew efficiency, you get the third chart on the right. This chart shows around a 400% increase in frac crew proppant throughput per quarter, per day, per month, however you want to look at it. Bottom line is when a well site needs between 100 and 200 truckloads of sand every single day, we have set ourselves up with a supply chain and safety challenge that is extremely complex. How do we efficiently supply that much product to a well site while remaining and pushing the limits on personnel safety? In 2016, along with a partner, we did some exposure testing in 3 key areas. We found a massive step change in the right direction using our container system versus conventional pneumatic systems. However, the exposure limits defined by OSHA are very strict, as they should be. As shown in the middle picture, that is 500 micrograms of sand, the amount of sand defined by the OSHA regulations for exposure during an employee shift. There are so many variables that could cause an employee or area to all of a sudden be over this PEL. This led us to continue innovating and try and provide the industry with a product that would ensure its compliance 100% of the time. We tried remote control panels to remove people from key areas of exposure, more targeted discharge, full enclosure along our belt systems, misting systems at the discharge, control cabins for the operators, as you can see on the picture on the bottom right. Ultimately, we kept coming back to how strict and variable these exposures can be. The control cabins and automation provide protection from exposure, but it is still not solving the problem directly of eliminating the dust. This is where and why we kept coming back to wet sand. We suspected it may be the definitive solution while also solving other problems within the frac sand supply chain. This is an extreme example, but the oil and gas industry continues to get more efficient, and it is trending in this direction. Here was a 5-day example where over 1,100 truckloads were delivered, over 100,000 truck miles were driven, and over 50 million pounds of sand were delivered and pumped at the well site. Again, this is great news for the community that is now disturbed for a much shorter amount of time. But does it create a more robust logistics and safety challenge, particularly for employees who are at risk to be exposed to silica dust? Yes. When there is 3 times as much sand being used on a day-to-day basis, that means there is more risk for overexposure. We believe the solution to this challenge is to deliver and pump damp sand. That way, the grain-to-grain abrasion that creates the dust is simply eliminated. This has been a 3+ year project for us. We started off with just the question, why is sand dried in the first place? Well, the answer to that question was due to limitations of the supply chain. Brief history. Originally, most sand pumped into a well was from a specific area in the Minnesota-Wisconsin area. It had then to move along the railroad where it needed to be transferred and stored multiple times before ultimately being pneumatically transported to the well and stored again before final use. Long story short, the railroad in many situations is no longer a part of the supply chain, and box delivery systems like PropX eliminate the pneumatic transfer during the last mile. We thought, maybe this is something we can accomplish. Why dry something when you are just going to get it wet again at the well site, simply to transport it? It doesn't make sense. We kind of figured, look, bottom line, if you could redesign this frac sand supply chain from scratch in today's environment with today's technologies, you would not build a drying facility in many situations. That's why we kept coming back to it. It's safer for employees, better for the environment, and saves money in many situations. Here's a visual representation of the last 5 years and what I just mentioned on the last slide. This is how the supply chain has simplified since we started working in the last mile space 5 years ago. First, in the original supply chain on the left, notice how many times the product is stored and inventoried. The regional supply chain in the middle mainly eliminated the railroad. This trend really gained traction in 2017. The middle regional supply chain cut over 1,000 miles, more than that in many situations, miles of transportation out, and was a huge step change in cost and surety of supply. Simplified the supply chain, was widely adopted. However, what we are working on is taking it one step further and eliminating the energy-intensive and complex drying facility. After the sand is washed, load it, send it to the well. A partner of ours did some silica testing during some of our pilot projects. On this particular test, all monitors were below the detectable limit. We're not an owner-operator of oil and gas assets or a frac company, so we do not have our own data, but we believe these results are repeatable. It is the same concept as the sand used to build sandcastles, damp sand that sticks to itself. The grain-to-grain cohesion with the moisture keeps the fines and dust out of the air altogether. This is a pretty staggering statistic. I certainly did not think about this until we began investigating it. Drying wet sand takes a tremendous amount of energy, to the tune of 300,000 to 400,000 BTUs per ton. It's incredibly energy intensive, operationally complex, and industrial. What all that means is it has a massive carbon footprint. Again, just to dry something, we get wet again when we get to the well site. You may be saying, Brian, what in the world does 300,000 to 400,000 BTUs mean? I have no idea how much that is on a relative basis. And to that question, I say I agree. We had no idea either. I had no clue what that meant, so we converted it into a different format. In the green circle, if all the frac sand used in the Permian Basin alone in 2018 was never dried and taken to the well site wet, like we kind of propose and are working towards, not only would it significantly decrease and maybe eliminate the employee exposure to silica dust, but it would also be the equivalent of removing almost 250,000 cars from the road each year. That equates to over 1 million tons of CO2 emitted in the Permian Basin alone just to dry sand. Sure, wet sand certainly has some limitations, as it is a new technology. But overall, there are a lot of positives to take away from this development. To name a few, the capital expense of building a mining facility is simplified and reduced. The cost to operate that mine is simplified and reduced. The dust potential at the mine and the well site is reduced, if not eliminated. The CO2 emitted drying the product is reduced. Finally, the mine can increase its output and simplify its processes by eliminating the main bottleneck, which is, of course, the drying facility. Here's a final visual representation of what a frac site looked like in 2016 versus 2021. Visually, the difference is pretty clear, but as we all know, the employee exposure limits are so small that even the massive step change away from the picture on the left may not always comply. That is why the industry continues to innovate to make the process cleaner, faster, and greener. Thank you all for listening. Thank you for support of our industry that provides so much for the world. Please let me know if there are any questions. I'll do my very best to answer them. If you don't get to it today, you can always reach out to me at brian.dorfman@propx.com, and we'll do our best. Thanks for the time.
All right. Thank you, Brian. That was really appreciated, and some really great, I think, information on a new technology. I love hearing about kind of the direction that this is going in and the work that you and your clients are working with. So I haven't been keeping up with the Q&A. Let's see here. So we have a few questions. The first, I think, is, are you in the Texas Permian market? I believe.
Yes.
Okay. Great. And what is the increased cost of transporting wet sand due to the additional weight? And, what are the logistical challenges associated with that?
Yeah, so the increased cost, to keep it simple, keep the answer simple, is call it 5% more. If the sand is 5% wet, then you have 5% more loads of sand. Now, that, if we want to convert that to like a dollars per ton type figure, like the industry typically uses for trucking and hauling, you could probably quantify it in saying plus or minus a little bit, but say $1 per ton more. So if you're normally taking, if you're hauling something 60 miles and that costs you $20 a ton, if you are hauling it 60 miles wet, call it $21 per ton. What we've seen is that figure is significantly overcome in most situations by the savings for not drying the sand. In a lot of cases, that the sand source can move closer to the well site, so you can, you can haul more weight per load, or just your distance that you're hauling simplifies things and reduces the cost on top of it.
Okay. How does the site adjust to keep the wet sand moving through the system?
Not sure I understand the question.
Okay.
You saying, are you asking what changes to the equipment need to be made?
Potentially, I'm not sure. Yeah, that was just the question. How does the site adjust to keep the wet sand moving through the system? So, are there any changes that need to happen on site when you're using wet sand versus kind of the traditional dry sand?
Yeah, there are. There are some changes to our original container design. There are some small changes to our belt design, and then I think I'm seeing a question that we have for screw augers. So that there's another piece of equipment that replaces the screws, the sand screws. So it bypasses that, because wet sand, obviously, if you have an auger, it's just going to channel into that. So that's a key piece operationally that's different.
Okay. Does wet sand stick in containers at all? And how do you remedy that if it does?
Yeah, it does. We've tried just about everything that we could think of on that. And yes, it does stick to containers. And that's why we have changes to the belt design. And to shorten the answer up, we use vibration to get it out.
Interesting. Okay. Is this technology applicable to legacy blenders, parentheses, blending tubs?
Yes. Yeah. We've run this in the field full time, at least testing with almost every major frac company out there.
Okay. And how wet can the sand be? How much is too much water in the sand?
Yeah, we would define it. I probably should have touched on that in the presentation. We would define wet sand, that can be actually run consistently at the well site at less than 10% by weight. after that it starts. It's not that it won't work, but you start to see different challenges. Like when it's over 10% wet by weight, now it's like a mud almost. And it if you're trying to haul it down the road, you might have water dripping out, and that just is different challenges. Now, most sand that comes out of the wet plant of a mine, is pretty wet early on, but within a couple hours of it just decanting, it will get down below that 10% figure. So it's not like you need to let it sit around for a significant amount of time. It's 10%, but we go 1 to 10%.
Okay. And then one last question before we need to move on. Very interesting question. How well does this system work in cold weather? So will this only work for fair weather frac crews?
Yeah, right now, all of the work that we do is in warm weather. We're optimistic that we'll get there. We'll figure it out in cold weather. But at the end of the day, when it's cold, water likes to freeze. And so right now, no, it's not a cold weather application.
Okay, great. Brian, I really appreciate it. I think that there's actually a few more questions in the Q&A box. So, if you wanted to take a look at those to see if there's any that you might be able to answer that we didn't get a chance to do at this point, but we do need to move on to keep on our schedule. So thanks for, I think, a really great and informative view on this new and emerging technology and way to address controlling exposure. So thank you very much.
Thanks, Bradley. Appreciate you having me.
Yeah, of course. Okay, our next presenter is actually myself. So I'm going to pull my presentation up really quick. Just give me a quick second. I'll share my screen again. Okay, so I think everybody should be able to see my title slide. This was added on as a presentation just simply because we have had an opportunity to work with this particular site. And so I wanted to make people aware of a website called www.silicasafe.org and the ability for folks in the industry to use it as a resource for compliance with the OSHA respirable crystalline silica standard. As you all know, As you all know, there are several key provisions of the respirable crystalline silica OSHA standard. A couple of the ones that we've talked about before in several of the presentations over the course of today and yesterday was the fact that, it instituted a new permissible exposure limit of 50 micrograms per cubic meter of air, calculated as an 8-hour time-weighted average. And then another aspect was the importance of a written exposure control plan, or an ECP. And there are several important aspects of this plan that I've listed here, including the tasks that workers might be involved in that would entail exposures, the descriptions of the types of controls that an employer would be using to limit exposures, including engineering controls, practices, and respiratory protection, any housekeeping measures that they would be using to limit exposure. The need to review and evaluate this plan to make sure that it's effective, doing that at least annually and updating it as needed. And then lastly, they would be needed to be made available upon request to each employee, any designated representative, as well as representatives of the Department of Labor, OSHA. And so in regards to this last aspect, the written exposure control plan, this website that I described, silicasafe.org, is a great resource specifically for those exposure control plans. So I do have a few polls that are sprinkled around the session today. And so before this presentation, were you familiar with the website www.silicasafe.org. And we'll give just a few seconds. So Courtney, in just a few seconds, if you couldn't end the polling. Okay, so not surprising, about 78% of people said that they were not familiar with this website. And so we kind of figured that that would probably be the case. And like I said, we wanted to provide a little bit more information on that, given that that's kind of the situation here. So I wanted to introduce you to this website. This is a copy of kind of the front page of that website. This website is actually developed by a partner organization from NIOSH called CPWR. That stands for the Center for Construction Research and Training, which is an international leader in applied research and training, specifically in the construction industry. And it's a partner of NIOSH. It serves as the National Construction Center for NIOSH. So they do a lot of our research in the construction industry. And when this website was originally developed, much of the content was actually focused on construction-related silica exposures. But over the course of the past year and a half or so, we have asked for content to be added for oil and gas related silica exposures to also allow it to be used as a resource for the industry. It is very well known in the construction industry, and it has actually been referenced in industry testimony. It was submitted as part of evidence in support of this OSHA silica standard, as well as being mentioned in the preamble to the final standard for the construction industry. And this website is also mentioned in OSHA's small entity compliance guide for the respirable crystalline silica standard for construction. So a lot of support in the construction industry. And like I said, it's OSHA's very much aware of it and has been supportive of it in that particular industry as well. So we foresee that they would be supportive of using this as an industry resource in the oil and gas industry as well. So I wanted to walk through a few of the aspects of what is located on the website. The first is kind of a general know the hazard section, and this is what's highlighted in the blue box that is on your screen now. If you click on that, it will come up with a list of options to select. There is a option specifically for the oil and gas industry that you can, I believe, go into and get more information. But a lot of this is just basic, why is silica hazardous? What is the risk? Who's at risk? So, probably a lot of this information you already know, but it could be a useful information for training purposes to bring more awareness about this particular hazard in the industry. The next section is a training and other resources section that I have highlighted here. And what we've included in terms of oil and gas resources are just a handful of things at this point. There is a reference to the small entity compliance guidance for respirable crystalline silica standard for just general industry and maritime, which is what we would fall under, and also links to hazard alert and that OSHA and NIOSH has put out in regards to worker exposure to silica during hydraulic fracturing that came out several years ago. And then there's also a link to the oil and gas well drilling and servicing e-tool that OSHA has published, which also has some content related to silica exposures. We would love to have more training and other resources developed, whether it's videos or other content. So if you can think of anything that you feel would be helpful to include in this training and resources section for the oil and gas resources, please let me know. The main section that I would really like to bring to everybody's attention is this control the dust, create a plan. And this is an interactive section in which you can actually create a customized exposure control plan. And that to begin, you would click on that green create a plan. So if you were to click on that, you would bring up this first step. It's basically a 3-step process. And this slide shows the first step in developing the plan. Starting at the top, there's an option that you can actually register. So that is shown in the blue box. You don't need to register to use the tool to actually develop an exposure control plan, but it does allow you the option to kind of confidentially save and update any plans that you might have in the future. This feature was added after the launch in response to a request from some contractors. But the organization, CPWR, that runs the website, all they ever look at is just the total number of registered and how many plans that are created. So there's never any attempt to find out who registered or to actually look at any of the plans. So it is confidential, and you can go back and, like I said, save plans that have been created, in your account. The first question that comes up is asked if you'll generate any silica on the job. So it has a number of different types of potential silica containing dust that you can choose from. So a lot of these are construction based, but we did add an option here to choose sand, particularly frac sand. And if you choose this, it will come up with a number of different types of tasks that might be associated. Now, because we were having to cooperate with an organization that did a lot of construction tasks, we didn't have a whole lot of ability to take some of these tasks away, but we did add things like frac sand cleanup, mixing, offloading, onloading, transferring. So you could select those in terms of the types of tasks that would be applicable to you. And then you would, once you've made the selections, the continue button on the bottom of the screen will turn green, and then you can move on to step 2. And so that is brings us up to this page. There's a whole bunch of information on this particular page. And this is intended to help with the requirement that you document the types of engineering controls, work practices, and respiratory protection that you'll use to limit silica exposures. So for this step, you're asked to control, how you plan to control that. And it shows that, you have the 3 types of tasks that are associated with that. Before we go into that, I do want to bring out a couple of things that say the use of, to find the exposure control methods in OSHA's silica standard, learn about air monitoring, and to find any studies and data on the use of controls, click here. So if you click that, this box comes up and you can look at these several options. A couple of the options that I specifically wanted to point out were options 2 and options 3. Option 2 provides a little bit more information and an opportunity to learn more about performing air monitoring. And then option 3 is studies and data on the use of dust controls. And so we have some summaries of oil and gas research findings, reports, and data that you can learn more about. So let's take a quick look at option 2 if you were to click that. Option 2 is performing air monitoring, and clearly we've talked a lot about that in terms of monitoring how or what the exposures are. There's some basic information, some good links, for example, to the American Industrial Hygiene Association website that has a list of consultants that are broken down by the type of work in case you need some assistance with industrial hygiene air monitoring, which can be useful. So there's some really good information there. Speaking of air monitoring, we come to our next poll question. And if you wanted to pull this up, Courtney, the poll question that we would like to ask here is, has your company, and this is particularly for those companies that have employees that could be exposed to silica, has your company conducted air sampling and exposure assessment to determine compliance with the PEL in the OSHA in the PEL listed in the OSHA respirable crystalline silica standard? So we'll let this go for a few minutes or a few seconds. Okay, so it looks like that the vast majority of folks said either yes or that it was not applicable. So I suspect that there's a lot of folks who may not necessarily have employees who would be exposed that chose that not applicable. And so it's really great to see that comparing the yes to the no, the vast majority of people have taken that step to do that air monitoring. And so that's really great to see. And particularly important, like I said, when we are evaluating the controls. So the next poll question is for those, again, particularly for those companies that have exposures that their employees might be having, do you anticipate that your company will be fully compliant by June 23rd of 2021 in using engineering and work practice controls to reduce and maintain all employee exposures to respirable crystalline silica or to or below the PEL? Okay, and the results from this, again, a lot not applicable, or but there's about 30%, 33 respondents said yes, which is really great to see. There's still a handful of folks that say no. I know we've heard a lot from some of our presenters over the course of today and yesterday that while they're making great progress in developing and implementing controls, that there's still maybe a handful of worker job titles that they still need to use respiratory protection for, and that engineering and work practices can't eliminate all. So maybe that's what that is in reference to, but it's still good to see that a lot of those individuals did respond yes. So great to see. Okay, so back to the website. Again, you can find more information. I just wanted to spend a quick second to show this option 3, studies and data on the use of dust controls. This is a list of peer-reviewed publications that particularly NIOSH has put out, but over the course of the past several years, I wanted to make people aware that these are up and online. If you are aware of other good studies that discuss silica exposures and the use of those dust controls, we would love to put them up here. Or if there are anybody out there that would love to work with us in doing some type of studies and getting these types of papers and studies out, please let us know, because I think this we would love to expand this library of studies dealing with this particular issue. Back to step 2, in each of these tasks that we have here related to sand and frac sand, you can choose the type of equipment or control. This still needs, I think, a little bit more building out. We have a couple of options here, but you can click here for examples of commercially available equipment and controls. So some of the companies that we have worked with in the past that have given their permission for us to post their controls, you can see here. And also, there's an open box that you can describe the specific tasks and equipment that you plan to use. Okay, an opportunity for another poll question. Are you currently using or plan to use an engineering control that's been developed within your own company, a commercially available control, or both to meet the OSHA RCS standard requirements to control employee exposures related to hydraulic fracturing operations? And so we're kind of interested in seeing, is there a lot of work that's being done in-house, or are people relying on off-the-shelf stuff, or both? Okay, for those that answered that this was actually applicable, it's interesting to see that there's kind of a combination. Most people, for those who answered, said that they were both developing stuff within their own personal company, as well as using things that are commercially available. So that's really interesting information. We kind of didn't know what the trends were, and so we appreciate sharing you all sharing that information. And so one thing that we get asked about a lot is kind of what are people using? And so for our last poll question, what kind of engineering controls will you use to meet the OSHA RCS standard requirements for engineering controls? And you can check all that apply here, everything from chemical coatings to vacuum collection and filtration systems, use of non-ceramic, non-silica proppant, gravity-fed modular bins, shielding and shrouding, wet sand techniques. So I think this is an interesting question and gives us a little bit of information on, what is the direction, what are people using that we don't really have a whole lot of information about. Okay. So what it looks like here from the polls is really a broad-based approach to the types of controls that you might be seeing or using out in the field. There's of the ones that were listed here, there's a number that listed vacuum collection and filtration systems, but also gravity modular bins or silos and shrouding appear to be the top three. But a number of other people included chemical coatings, vacuum collection system, wet sand. So there does not appear to be kind of a dominant control that is being implemented, at least amongst the individuals who responded, which is very interesting. So thank you. Okay. So after you've put the types of controls in your exposure control plan on this website, it brings you to step 3, which is basically just kind of finishing and completing the plan. There is space here to include your name of the company, the person completing the plan, description of the work. It includes all of the information from your controls that you had inputted in the step 2. And in those boxes that you see that are kind of highlighted yellow, there's additional information or text boxes where you can put information about housekeeping and establishing, demarcating, and limiting access for areas, training, all of the aspects that you would expect to find. There's additional links that you can click to that take you directly back to the OSHA silica standard for the industry, which might be helpful as well. And then when you click continue, that brings you to kind of your final plan where you can print it, download it, save it, do whatever it is that you might want. Like I said, it can save it in the system if you have registered so that you can reuse it, maybe just changing the name, location of the site, things like that. So it's, like I said, just one additional resource that you may not have necessarily been aware of, but that you can use for finding new information, using it for your exposure control plan, things like that. I have one last poll question, and this is actually not anonymous. All of the other questions that we had asked previously, we did not monitor who was answering what, but we would like to know, would you be interested in providing further information on your specific control so that it could be included on silicasafe.org as an option? I had showed you before that we really want to populate this with current controls. You can provide your own resources in terms of what you would want to have linked on here. So if you do say yes, please note that your name will be recorded, and that will allow us to be able to contact you for additional information so that we can populate this and make it as current of a resource for folks in the future to kind of take a look at what some of the options are that we are aware of. So for those of you who said yes, I very much appreciate that, and we'll be reaching out to you again in the not too distant future to potentially get some more information on how we can list your control on this website. So that is it. If you wanted to close that poll, that is it. So I am happy to just spend a couple of minutes. I think I went about 3 minutes over, but we have a 10-minute break after this, so I can spend a couple of minutes. Let me check to see if there were any questions that came in to the question. So I don't see any other than just, again, making sure that, even if you didn't answer yes to the question, if you do want to have your system again listed as controls or other technology listed in here, please, and this is true for all of the speakers that were part of the presentations yesterday and today, I invite you to at bking1@cdc.gov, and we'll be able to get this information online. So I don't see any additional questions that have come in. So at this point, we have about a 5-minute break. We will, let me stop sharing. And we will be coming back in 5 minutes at 11:25 Mountain Time, 1:25 Eastern. So we look forward to our next presenters, and I'll be bringing that agenda up soon. So we'll be starting again in 5 minutes. Thanks all. Hi, Brendan. How are you?
I'm good, Bradley. How are you?
I'm doing good.
Good.
Hope your morning's been well so far.
It's been great.
Great.
I've enjoyed these presentations.
Oh, good. I'm so glad. I hope it's useful for folks. Just as an FYI, I'm sharing my screen right now. I will be bringing up the agenda on the next slide. And after I stop sharing that, then you'll be able to share your screen and begin.
Sounds great.
So we just have a couple more minutes and then we'll get started.
Sure.
Okay, welcome back, everybody. It is 11:26 here in Denver, 1:26. And I just wanted to welcome everybody back. Again, as our break slide shows, thanks again for all the advertisers to the associations and organizations who helped to get the word out. What we're going to be talking about in this next session, we'll be hearing from three speakers, Brendan Gilbert from Solaris Oilfield Infrastructure, Greg Beery from Benetech, and Sean Furlong from Source Energy Services. And then we'll be able to take another break at 2:40 for about 5 minutes. That's Eastern time, 12:40 Mountain time. So our first up is Brendan Gilbert. Brendan, I'm going to stop sharing my screen and that will allow you to share yours. And then while you're starting to share your screen, I will go ahead and give your introduction.
Sure. You guys see my screen okay?
I am not seeing anything.
All right.
I can see it fine.
Okay.
Bradley, can you not see it?
Let's see here. Hold on a minute. Maybe. Oh, there it is. I can see it
Okay.
now. Great. Sorry
like
about
other
that.
people
Very
can.
good. Excellent.
Okay, so let me go ahead and give an introduction really quick. Let me pull up my. Okay, so Brendan Gilbert. Mr. Gilbert serves as Solaris's Senior Vice President of Service and Quality, overseeing field service operations, quality and continuous improvement, and software development. Before joining Solaris, Brendan spent several years with Schlumberger in assignments both in the US and the Middle East. Brendan started his professional career in the military, serving on active duty as a captain in the US Army. He is a licensed attorney in both Texas and Pennsylvania. So Brendan, the floor is yours.
Great. Thanks very much, Bradley, and we appreciate being able to speak with everybody today. So real quick, I'll just talk through what our agenda is. We'll briefly describe what Solaris's equipment is, what we offer for the completion services in the industry. We'll talk a little bit about the macro industry trends. We did see Mr. Dorfman talk a bit about that, and so some of the information I'll share will be very similar to what he's already shown, so we won't spend a lot of time on it. And then what we do want to get into is actually, let's talk about some of the engineering and behavior controls that we're implementing or that we have already implemented to address compliance, and also how that ties nicely into trying to bring some efficiencies to the well site for a more safer, more cost-effective solution going forward. And so, I think the most important thing to start out with is just a quick overview of what Solaris offers in the completion space. When we were founded back in 2014, what we looked at was trying to find a solution for what has historically been a challenge to the completions industry, which has been that low pressure, or what they call the backside of the well, proppant delivery and storage at the well site. We saw lots of logistical challenges there. We certainly saw storage challenges. And then of course we saw the knock-on effect, which was the messiness of the well site, the inability to become efficient, and the challenges that our operator customers had in trying to increase the amount of stages they wanted to complete per day. So we came up with a vertical solution. We took a solution that has been out there in other industries, made an application to the completion space for oil and gas. We've then since iterated beyond just being able to provide a proppant storage solution, and we also have a chemical storage solution, particularly both for the surfactants and the friction reducers, as well as for acid. And then we also have had, since the beginning of our company, a water storage solution. And all of this is just designed to provide more volume storage capacity on site at a lower footprint, with the capability to be able to automate this system, so that we can drive reduction in personnel, reduction in footprint, reduction in demand for last minute logistics planning, and to increase our customers' ability to create efficiencies. But before we get into the specifics of the engineering controls, particularly around our sand system, I just want to quickly take a step back for a second and let's look at where we are versus where we were. And we saw yesterday in the presentations about when we first looked at the compliance with the silica standards that are already in place in other industries, particularly the mining industry. When we saw that we tried to apply that to oil and gas back in 2010, 2012 timeframe, the realization was that the equipment was just not where it needed to be in order to meet compliance. And since then, we've certainly seen great changes in that. Whether it be with a containerized box solution or a silo system, those engineering changes have been a great improvement to what we had about a decade ago. However, in that same time period, we've also seen a drastic change in the type of proppant we're using and the volume of proppant we're using. And so what you're looking at here on the left is just a graphical trend analysis showing how many million pounds of proppant are being pumped per day per frac crew. It's a drastically increasing trend. And we heard earlier today about how We've seen on well sites that customers are pumping upwards of 13 million pounds of sand a day, and that is absolutely true. We see that. We're actually handling several jobs today where we are pumping on average between 12 and 13 million pounds of sand. At the same time, we're also seeing a change in where they're sourcing the proppant. Whereas about a decade ago, proppant was primarily sourced from the northern white sands, from the mines up in the north. Because there's been pricing pressure and because there's been this increasing demand for more proppant per day, it has driven this regionalization or localization in sand mining. So the question is, okay, well, what does that mean? Well, ultimately, it has an impact on the quality of the sand itself. And as we heard earlier today from Tom over at Arkham, there is a change in the type of proppant when you go from that northern white to a regional sand. And we talked earlier today, we heard about the shape of that proppant and the impact it has. We're just going to step back here and take a look at on the impact on turbidity. The northern white product on average was roughly around 70 FTUs, which was well below the API recommended standard for frac sand. Today's regional sand for that 100 mesh count is nearly 735% greater than what the northern white is. The translation for all of that means is that what we are dealing with now is a sand that is dirtier, it's dustier, and as it gets transported to location and then it gets used on location, it creates a greater risk for silica exposure. These trends are going to continue in this direction. We don't think that there will be much of a change in this direction, at least not in the near term. Who's to say if the regulatory bodies step in and force a change on the quality of the sand, but I think it's more likely that it's going to be incumbent upon the partners who are working at the well site to find the right engineering and behavior controls to be able to help handle the type of proppant that is used today to allow operations to continue. And so that's where Solaris has been focused, is trying to find solutions for today's proppant demands and proppant quality. We've seen versions of these pictures already on multiple slides over the last couple of days, so I don't need to spend a lot of time on this. What I think it's probably important to highlight here is when you look at those pictures on the left from back in the 2010 to 2012 timeframe, keep in mind that was when they were using a better quality sand product. What you're seeing nowadays, and you saw that in some of the slides from some of our other partners over the last 2 days, is today's engineering enhancements and controls can handle a degraded sand with better efficiency and with a cleaner well site, provided that all the partners who are handling the product adhere to the engineering and behavior controls that are put in place. And our approach has been quite simple to it all. Our framework is shaped around 3 key principles, which is let's simplify the number of touch points required to operate the system. Let's automate the operation to reduce personnel and unplanned logistics that are required. And then let's streamline the well site footprint through an integrated operating system, all designed to create efficiencies, reduce exposures, and allow for a more safer operation in the oil field. So let's dive deep now and let's just take a look at what is the proppant path for a sand silo system. And what you're looking at here is an aerial view looking down on our silos. We have a 6-pack of silos here, and in the center between the 2 3-packs is the T-belt conveyor. And we're now going to dive deep and just look at the engineering controls we have put in place and are putting in place in our systems to be able to address containment and then mitigation and filtration to ensure that the site stays cleaner and to reduce exposure. So whether the sand is brought in to a Solaris silo on a pneumatic truck or on a belly dump truck, because we do have the ability to transfer from belly dump into the silo. Right now we have that through a transfer system that goes into a tank and then is pneumatically filled into the silo. We're also working on a top loading solution, so it's completely gravity fed. no matter which way it goes, the first step in understanding what's important in protecting and containing the sand as it moves through the well site starts at that fill tube. The important part there is making sure that we maintain a consistent PSI that does not exceed the levels that would cause greater agitation than necessary. And so we do ensure compliance with any time we have pneumatic loading, that when that hose is hooked up to the fill tube, it's at 12 PSI max. On top of that, when you disconnect a hose, you don't want to have an open port. And so where we initially started back in 2014 with manual caps that you would put back on to close back up, that relied on human behaviors. And the idea, again, is to streamline and reduce the amount of human input so that you can get more of a consistent result in compliance. So we've now started to modify our systems with an auto closing fill tube cap. So as soon as you withdraw the hose from the fill tube, that cap closes and then keeps the sand and proppant materials contained within the silo system. As it's being loaded into the silo, we have had since the beginning of our creation of the silos, a filtration cabinet that sits at the top of our silo systems. Inside there are 16 MERV 10 rated filters. Those MERV 10 rated filters get purged with pressurized air every every 30 to 90 seconds, just depending on the type of proppant being used and the volumes being pushed through the silo. It's important to keep those filters clean, just like it is important to keep your vacuum filters clean. We keep those clean so that we can keep the system contained and avoid any dust or fugitive dust coming out onto the well site. And also another key feature is focusing on ensuring you don't overfill those silos and you maintain inventory levels that fit within the containment system's capacity. And by adding not just the radar sitting on the well site, but also by providing real-time inventory management that can be available in the data vans, on our phones, on our tablets, or on our laptops, whether you're operating the job from the well site or whether you're observing operations from an operations center or the comfort of your own home even these days, that real-time inventory management is available. It tells you how much sand you have available in the silo, the rate at which you're pulling sand from the silo, which is read from belt scales that we have underneath our silo system, as well as the amount of sand that you're actually running for that particular stage. Again, giving visibility to the customer drives a better behavior and more adherence to compliance and efficiencies. So then as that dust now travels, or sand now travels from the bottom of the silo, it goes on to what's called a shuttle belt. And our silos are gravity fed. Once the sand is loaded in the silo, the sand sits on top of our shuttle belt. It is not pushed into the hopper using pneumatic air. It is not pushed or controlled through slide gates, which can have mechanical failures or not create a great seal. In fact, that sand sits directly on the silo, and it is moved when the silo's shuttle belt decides to, or is turned on. And when that shuttle belt is turned on, then that sand is moved over and then delivered onto that central T-belt. That's that green part if you look at this top key up here. As we move that sand from the shuttle belt over to the T-belt conveyor, we keep the entire system enclosed. It's important to keep it enclosed because then you have containment. So our shuttle belts have the tarping enclosures on it so that any dust or agitated exposures stay contained within the system. And then our T-belt conveyors are fully enclosed on the top and on the sides on both the horizontal section as well as the incline section. And then as it reaches the incline section and delivers the sand into the hopper, we have an enclosure that is installed on the hopper itself. And as we heard yesterday, one of the key common denominators of all the systems today that are handling proppant delivery to the well site is the hopper. And whether we use a containerized system in box form or a silo vertical system, we still need to put sand into that hopper, and that is a key exposure point that every operator and every pressure pumper is focused on today. We have created some automation so that that enclosure that you're looking at here can stay on the hopper 24 hours a day, 7 days a week from the beginning of the operation to the end of the operation. And we'll get to that in just a minute. But before we talk about that hopper and the automation created to that, it's also important to take a step back and realize that we still needed to put some emphasis on the discharge head. And we've heard about the importance of making sure you reduce the agitation of sand. And that's, again, designed, if the more or the less you are agitating the sand particles, the more likely you are to reduce the silica exposure. So we reshaped our discharge heads. We added a vibrator to avoid any sand collecting inside the discharge head to ensure that that sand slowly or slides smoothly off of the belt and into the hopper. And we also added a motorized brush to make sure that that belt stays clean so it doesn't carry any sand on the bottom of the belt back towards the rear of the system, creating the exposure point away from the hopper. Now, once you get to the hopper, once the sand is in the hopper, you say, okay, well, how is it possible that you can have that fully tarped and enclosed if, as we saw in some images from yesterday, there has to be a person standing there to check the level of the hopper to ensure that the proppant stays in the hopper and ensure we don't starve the screws or overfill that hopper. Well, that was the first area where we saw an opportunity for automation. And we have a patented system called the auto hopper, where we stick a probe inside that hopper. You set a set point that is customized to the design of that hopper. And at that point, that probe operates those shuttle belts on the silos and tells that shuttle belt when to speed up, slow down, stop, or start to ensure a consistent level of sand in the hopper at all times. By doing that, we no longer need a person standing out next to the hopper, putting their head inside the hopper and manually operating when to speed up or slow down the sand delivery. We've moved that role into the data van. We've made it remote and we've made it automated. And so now that role is there to monitor, watch the set points, select the next silo for operation, and not to manually increase or decrease. By doing that, you eliminate one person from a high exposure area, and you also then contain that hopper for the full operation. Now that we've contained the dust system or the sand system, and we've ensured that there is a full enclosure from the time you hook up a hose or gravity feed from the top of the silo to the time that you put it into the hopper, it is important that we do have a local exhaust ventilation system, because containment is one thing, but then there still is filtration. And so what we've done is we've started to modify those dust cabinets that sit at the top of our silos with a local exhaust ventilation unit that pulls the sand from any fugitive dust from along the T-belt conveyor and from the top of the tarp of the hopper back through our system and through that filtration system at the top of our silo. These hoses can be connected and modified and customized to whatever the frac design is. And so while we are working on static connection points along the T-belt, and we already have connection points at the incline part of the T-belt as well as at the hopper, it can also have additional ports to be able to capture any other areas, particularly as we deal with challenges that come from ambient dust, wind shears and the like, to be able to create an extra opportunity for our customers to pull any fugitive dust that's coming, maybe even from unexpected sources that can't be well contained, get that through the filtration system, and again, lower the risk of exposure at the well site. And then what we thought we'd do is we'd share the tests. These are recent tests that we took last month on a system that had all of the features that we just discussed above. Now, it's important to note that we've not yet outfitted all of our systems with this LEV because we're still testing the feasibility of adding more ducting to be able to add more opportunities for our customers to use that vacuum filtration system, not only for our location or our equipment, but also to assist with their equipment. But what we have seen when we've implemented all these engineering controls is that we are below the action limit. And we've also tested respirable particles that are not otherwise regulated, and we're well below the PEL for those. I think the important step here is we take a look at these results, we think there's still more opportunity to be able to refine that. And if we look at these results, you say, okay, well, there still is some potential exposure while well below the PEL sitting at the blender. We've noticed that for some time. In fact, we have been doing testing for well over 2 years, over almost 3 years on our sites. And we've consistently noticed that that blender area, which is not Solaris equipment right now, is still a potential exposure area. And so we took a look and said, well, we hear that the T-belt conveyor system, the hopper, the screws, and the blender are high exposure areas. Perhaps this is an opportunity for innovation that also can drive compliance and efficiency. And that's where we come up with the solution that you're seeing here, which we just launched a prototype and will be going out for field trials next month. And this is our integrated blender solution. And here what you're seeing is we have eliminated the T-belt conveyor. We have eliminated the hopper, we've eliminated the screws, and we've moved this blender directly in between that 6-pack of sand silos. And as that sand moves off the shuttle belt, it goes directly into the blender tub. What we're adding here then is the opportunity to continue with rates consistent with what our operators are seeing today, as well as adding 3 blender tubs versus the conventional 1 blender tub that we see out on a well site right now, with the opportunity, again, to integrate and automate the system. And so now the entire sand and blender operation and your inventory management of your proppant materials can be run from the comfort of a tablet that can be run anywhere on the well site, including from inside the data van, reducing the number of personnel needed to be able to operate completions operations, reducing exposure, eliminating some of the key points and the key challenges when moving sand, which is that hopper, that T-belt, and then those screws, and also creating an efficiency, an opportunity for operations to run and keep up with those trends that we saw earlier today, which are more pounds per day and more stages per day. And we look back on, where we think the completions trend will be, is we do believe that this system, where you can find an opportunity to help our customers achieve an opportunity to run 18 to 20 to 22 hours a day to be able to move the proppant at the volumes they would like, and yet still remain well below the PEL, stay compliant with the regulatory bodies, and create the efficiencies. That just creates a safer place to work. And then the last thing I'll just highlight here is this entire system. Every component that you saw here today, from the silos to the belts to the blender, is all electric. And while we are powered by diesel generators on some of our fleets today, we are also powered by electric turbines on some e-fleets. And we are fully capable of running either off turbine or grid for electric sourcing of power versus diesel. And so Bradley, that's it for our presentation. I don't know if we have any time for Q&A, but I'm happy to answer questions. If I don't now, I will follow up with any questions that were put on the Q&A chat board.
Yeah, great. Thank you very much. We only have a minute or so, but we can, I think, ask a couple quick questions. There was a comment that Robert Waterhouse said that, a lot of the controls that you've incorporated make being safe easier, and that's a really awesome hop control based on his presentation from yesterday. So, I agree, the elimination of positions that need to stand directly at that blender, I think is a great innovation. Of the presented engineering controls, what % of your active fleets are actively using them in the field?
Yeah, it's a good question. The LEV is our newest one. So right now we only have 2 systems out running with the LEV. Our ability to retrofit and deploy those is very rapid. For example, we can do 1 fleet a day. We have our own manufacturing facility. So we're prepared. Once we get the next round of testing, we're prepared to do a full deployment and have all of our systems that are out there in the field running in time to be compliant with June's deadline. The auto hopper system is already running on nearly 70% of our active fleets today. It's available on 100% of our fleets. The challenge is just dealing with change management in the field, getting customers to be willing to adopt that automation.
Yeah. Okay. Just a couple quick questions, if you could answer them quickly. How are the silos stabilized for wind, and can these systems use dust reducing additives? And then after you answer those, we'll move on to the next.
Yep. So wind rated, when empty, it's rated for just about 100 miles an hour. Once you add the sand to the system, then the wind rating goes up substantially. As a recent point, we had those hurricanes come through last fall into Louisiana area, and our silos were up the entire time and sustained no damage. As far as adding dust suppressants, we have looked at that. We've actually looked at a misting system. There are ways to be able to do it. We think the best place to probably do it is at the hopper when it sits inside that contained area. However, we are looking at ways of being able to add it earlier on at the shuttle belt. But that's not to say that those are the only two areas. I think it does not impact our operation.
Okay, great. Thank you for those. We very much appreciate your participation today and really great information, exciting controls that you all have been developing and putting out there. So thank you very much.
Yeah, thank you, Bradley.
Yeah, so if you could stop sharing your screen, which I think you just did. Our next presenter is Greg Beery. Greg, if you wanted to start sharing your screen for your presentation while I introduce you. Okay, we're seeing your screen now. Okay, so Greg Beery has been working in the bulk material handling industry for 35 years. During his career, he has been involved in the mechanical systems design, global project management, technical sales, and contract consulting. Greg is a graduate of Colorado State University and currently resides in Montana. His presentation will highlight new technologies developed under a collaborative research agreement between NIOSH and Benetech USA to bring research to practice with cutting-edge technologies to control respirable silica dust in the frac sand and mining industries. So, Greg, the floor is yours.
All right, well, thank you, Bradley, and I'm certainly happy to be here. As you mentioned, we're going to talk about a few new technologies, particularly as they relate to the fracking industry, but then the evolution of those technologies as it carries into mining. And we saw a presentation yesterday by Andy Sakala where it kind of went the opposite direction and had technologies that were developed for mining that can apply to the fracking industry. So either way, there's benefits to be shared. And just a little bit about Benetech. Benetech has been around for about 40 years. They started out with chemical suppression and have proprietary product that they blend in 3 different areas in the US and about 300 employees, as well as service technicians. And one of the main goals for Benetech is total dust management and to incorporate safety by design into some of the equipment that they manufacture and supply. So along that same line, you can see their toolbox, and the toolbox is designed to allow a combination of technologies to reduce dust, prevent spillage, improve material flow, and ensure compliance. So the first thing we want to talk about is at the frac site, and this image is one that was provided by NIOSH, and you've seen it before, but it just kind of shows the general layout. And as we all know, there's significant respirable crystalline silica at various locations in the frac sites. The one that we heard mentioned yesterday as a primary area of focus during the OSHA presentation was thief hatches on sand movers. And realizing that the industry is moving towards containerization, there's still quite a few sand movers out there. So that problem is one that does need to be addressed, and it has been addressed. So looking at the NIOSH exposure study that was done as related to the OSHA mandates, you can see that 51% of the samples exceeded the OSHA PEL at the sites where the samples were taken. And everybody's well aware of the controls that are going to be enforced as of June 2021. So our timing is good to have something in place at that time or before then. So the collaboration plan is kind of, to give you some background and highlights, basically the goal was to produce a commercially available product for the fracking industry to address the issue of respirable crystalline silica, and particularly as it is related to sand movers at the thief hatches. The collaboration on the side of Benetech is as a national manufacturer and distributor of commercially available products to take research into practice and make it available to the public. So what was developed in this case is the Dustinator, which is a commercial product design, taking advantage of the research that was conducted by NIOSH and the commercial development and fabrication and design expertise supplied by Benetech to come up with this product. It's interesting, we've seen these pictures before, but there's a good view on the right-hand side of what it looks like when it's visible. This is the Dustinator for the frac sand movers, and it's a passive system. The design was made more compact. It is weatherproof. It's designed out of a robust aluminum structure to take advantage of the weatherproof aspects of aluminum, but also the weight savings. The cartridge filters are MERV 15 that are used, which exceeds the 95% efficiency with 1 to 3 micron particle sizing or respirable crystalline silica. And the before and after testing is conducted by NIOSH. So all of this information will be published at some point in time, documenting the results, and that'll be good data to have access to. As far as the preliminary results, those have been documented. The equipment does perform as designed. We want to do some final field testing though, and document those results too for the final publication. So the unit itself is self-cleaning. The sensor array allows it to report system status. It's internet enabled. It's also satellite enabled. So if you're in a very remote location and you're using this equipment, you can communicate from wherever you are. In this case, with the passive unit, the power and air is minimized, and that can be supplied by onboard diesel. Here's a handsome lot. This is the NIOSH personnel. As this technology evolved from passive to active, there was a reason for that, and the reason is respirable crystalline silica exists at the frac site, but also before the sand gets there, it's processed through the quarry and mining facilities. And then after the oil is produced and refined, we've got petroleum coke. So there's several other mining related industries where this technology can apply. So why are we going to talk about conveyors? The reason is in relation to respirable crystalline silica, and also the safety features that we want to address. The chart below shows it by machine and by activity where the problems lie. And in the mining operations, the conveyors are the most dangerous piece of equipment on the site. So that's a natural place to attack. By activity, where injuries and fatalities occur on the safety side of the formula, is machine maintenance and repair. So as we'll see as we get into this, those are also areas where a large portion of the respirable crystalline silica is produced, especially at the transfer points. So the tasks, as we evolve in this technology to improve conveyor safety while also addressing the respirable crystalline silica, is number one, monitoring. So there's a sensor array, multiple sensor data can be supplied and is for communication via cell phone or HMI web interface, and alerts can be sent when equipment is not performing or when there's an error. So as I mentioned, 85% of the dust and spillage in conveyor systems occurs at the transfer points. And we've heard in other presentations that as material drops, obviously, there's air entrainment and then there's displaced air when it lands. So all that turbulence is an important area to attack as far as curing the problem at the source for spreading the respirable crystalline silica throughout the rest of the operations. So the engineering controls is what we're primarily focused on here, and the engineering controls are designed to reduce the spillage, also at the same time reduce the RCS dust exposure, and to incorporate safety by design. So it's kind of a natural combination for NIOSH and Benetech working together. NIOSH has tremendous expertise on the research and development side, as well as a passion for safety. And Benetech on the industrial side has worked in a lot of these different types of facilities and developed unique products to not only address the problems, but also to allow ease of maintenance and service, and therefore creating safety. So what we've come up with, the evolution of the dustinator, is what is termed as a smart zone for respirable crystalline silica. But that's a mouthful. So the smart zone design concept is smart sensor actuated equipment, incorporating the dustinator as the air cleaner, a smart spray bar system, which is called the puck system, for introducing a chemical binder very intermittently, but that allows that to also communicate and be actuated with the same sensors. And then the max zone for containment and air velocity control. And all of this is web enabled. So the results of this combination of technologies and equipment is the smart zone, which allows for safer and cleaner operations, less housekeeping required, fewer people around dangerous equipment, and not as often. Maintenance is reduced because it's made easier, simpler. It can happen more quickly, and it can happen with fewer people. And we'll show that. The dust reduction results, the before and the performance of the equipment as designed is documented by NIOSH. We'll also have some after results. We have an installation going into service in May, I believe, that will be documented with the before and after testing too, which will be great, and that will be published. So the ultimate goal here is to reduce worker exposure to respirable crystalline silica. So the dustinator for the belt conveyor application is an active system. So you can see a little bit different design, not much, it's very similar. You can see the inlet port for the blower. It, again, is self-cleaning. The sensors, sensor array is web enabled. It has the ability to report system status, so that gets into some of the reporting features that come into play downstream when OSHA is looking for some of the documentation that's readily available. Again, it's a robust aluminum design. It has multiple labyrinth seals for sealing, so no dust is going to be expelled from the enclosure except for where you want it to go. Again, the MERV 15 filters, which exceed 95% efficiency in the 1 to 3 micron particle size. So in talking about that equipment, we mentioned the dustinator, we mentioned the smart zone, we mentioned the max zone. So I want to just run through it very quickly to give a little better idea of what's going on here. And this is the containment system. This is what was referred to as the max zone. And it's an enclosure. It's entirely bolted construction. So there's no hot work required to install or maintain this system. We'll take a little look at the video here and give you a better idea. There's some unique design concepts incorporated into this too. The liners are internal and they're externally adjustable. So there's no confined space entry issues when it comes time to repair or replace liners. And in aggressive materials, that's a constant. They do have to be replaced. When they do have to be replaced, it can be done by one person. That's a 4-foot section, weighs 37 pounds. Take it out, put the liner on, put it back in place, replace the bolts, and then use the cam, the little orange piece on the outside there that turns to adjust the liner. The difference between this and what typically is found in the field is liners, when they're replaced, are longer. It takes more than one person to do it, and more often than not, you've got somebody in the field standing on their head with a welding torch trying to line up liners and make it line up throughout the system so you don't gouge and groove the belt. And when that happens, of course, you can't seal it, so you've got all the ultrafine dust just puffing out all along the containment system. This eliminates that from happening. To look at another part of it that we mentioned was the puck system. Now this is interesting. This is so that a binder agent can be added after the purge cycle of the dustinator. So if the dustinator is purging once every 20 minutes, say, this runs for 20 to 30 seconds in sync with that purge cycle. The same sensors that control the back pressure and the purging within the dustinator also actuate this unit. And what's unique about this is, and why it's called a puck system, is it's a solid chemical that's added to this. It uses plant water supply, or if there isn't plant water, then you can put a tote nearby that's got water available and use a pump. But the chemical itself does not require bulk transfer and storage, because if you think about Tide Pods, it's a little hockey puck shaped solid chemical, and using the venturi of this effect of this system, the water is metered to run over that puck, and the dry chemical is absorbed and then metered into the supply so that it's applied at the correct dosage. And the only reason for having this in the system, the dustinator is doing the work. It's removing the respirable crystalline silica from the system, but when it purges in a cake and back onto the conveyor, this gives us an opportunity to then treat that for a short period of time as that runs by on the conveyor, and apply a binding agent to give it more residual effect as it continues its path downstream. So that's the logic and description of how that works and why it's there. So this is looking at the field installation preliminary design drawings, or 3D drawings. And you can see there's the max zone. And you see that it's elevated here, and there's a reason for that. The reason being the air that's going between the two crushers and out towards the end of the conveyor is controlled internally with baffle curtains, staggered baffle curtains, and then there's a certain volumetric ratio that allows us to take the velocity out of that airstream and allow some dust settling. And then by the time it hits the dustinator, it's not just ripping through in gale force, but some settling has occurred and the velocity has been slowed. So at the back end of this, there's also an insert available, this particular max zone that would allow soft loading and center loading, and it's an adjustable spoon. Again, everything's adjustable from the outside. In this particular installation, we're not going to use that. It's not necessary, but downstream, if this were to be put between two belt conveyors, say, for instance, without the crushers, and that might be something that would want to be added to the system. But anyhow, as you look, there's the max zone, there's the dustinator, and then here's the little puck system down here. So that's just a general overview of what you're looking at there. And that's a quick run through, and hopefully we've got a little bit of time for some questions here, but there's a sand plant in the back, and it's a nice clear day with no dust in the air. So thank you very much. If there's any questions, I'll do my best to try to answer.
Great, thanks, Greg. I appreciate your presentation, and you know, you're working with NIOSH kind of on these research to practice efforts, and thanks to some of my NIOSH colleagues, Grant King in particular, for taking a look at how some of this technology can be incorporated into oil and gas industry operations. So just for folks, a reminder, there are, put any questions in the Q&A box. I guess the one before we go to a couple of the questions there, I know that you had mentioned you were working with NIOSH and kind of this is as a research to practice, and that you have some field trials coming up. We're very much interested in looking at kind of the data that's generated from that. What is your timeline in terms of what it is that you're thinking to have some of these components like the dustinator, available for, integrating or for, trialing for individuals? Are these components available now, or is this still more, are you waiting to kind of get the field trial component completed before making available, or kind of what's the timeline for that?
Well, the components are commercially available now. A lot of what you looked at on that system has been supplied for years. As far as the dustinator, the commercial unit is fully designed and ready to be implemented into the final field test, and we're anticipating May for that. Okay.
Very cool. And one question that came through, how long does it take to erect the unit? Kind of what's involved with incorporating a lot of this into a practice or procedure at a site?
On the dustinator for the sand movers, it's just a matter of making sure we've got the measurements right, and then connecting the flange. Now those can attach with a magnetic base too, which is built into the system. I'm glad you brought that up, because that's an integral part of it. So as far as in the field, a day. And on the mining side, where we looked at significantly more equipment, in that particular situation, that's probably 3 days to get that installed, really. A day to tear it out and 2 days to put it in.
Okay, great. I don't see any additional questions. We are at about 12:15 right now, which was our stop time for this presentation. So unless anything comes through real quick, hold on a sec. Oh, Elizabeth says thanks. No. Okay. Thank you, Greg. I appreciate this. Great presentation, and thank you for participating in our event today. So we will move on to our next presenter, Sean Furlong. So Greg, if you would stop sharing your screen, and then we will ask Sean to go ahead and get on and share his screen. And as he does that, I will bring up his introduction real quick. Okay, so the next presentation is from Sean Furlong. Mr. Furlong is a Canadian registered safety professional with a Bachelor of Science in Geology and a postgraduate safety engineering diploma. He has over 20 years of international oil and gas industry experience, with the majority of this directing corporate quality, health, safety, and environment systems. Mr. Furlong is currently the Vice President of HSE for Source Energy Services, Western Canada's largest producer and distributor of Northern White frac sand. So Sean, the floor is yours. And you are on mute.
I have it.
There you go.
Thanks. Thank you, Bradley, for the introduction and the opportunity to present today. Good day, everyone. My name is Sean Furlong with Source Energy Services. And today we're going to do, I'll do a quick introduction on the history of Source Energy Services and who we are and what we do. We'll talk about some of the silica dust lessons that we've learned over the years, and then how we've applied those silica dust learnings into our well site Sahara unit through engineering and design controls. So first, a little bit about Source. We are a fully integrated frac sand company. We do mine and produce Northern White sand in Wisconsin. Then we rail it through our fleet of rail cars to one of our Western Canadian rail terminals, where we store it. And then we do last mile logistics to the well site, where we can deliver it to our Sahara well site, our Sahara storage unit, and deliver it right to the blender. So providing products and services from well site to mine site, or mine site to well site, sorry. A quick look at our history. So we've been involved in frac sand for over 20 years now. We started as sand source with some basic in-basin sand storage in 1998, and continued to grow with the industry. By 2013, we had our first Northern White frac sand mine in Wisconsin, and our first Sahara unit was developed. As we continued to grow, in 2014, we had our first unit training capability terminal in Wembley, Alberta. And as we continue to expand our rail or storage network. In 2015, we refined and integrated our last mile logistics offering. And then 2018 opened our second unit train capability terminal in Fox Creek, Alberta. Brings us to today in 2021. We operate 3 mining and production facilities in Wisconsin. We average about 2 million metric tons per year. We have a rail car fleet of 2,200 rail cars. We've got about 200,000 metric ton storage capacity in the Western Canadian Basin within 8 rail terminals. 2 million metric ton throughput through the terminals. And we now have 8 Sahara units operating within Canada and the US. So I'd like to talk a little bit about our overall corporate silica dust management plan. Like most companies nowadays, and we've heard a lot of these plans over the last couple of days, you know, we do full health monitoring. We have our full program where we ensure our employees are not being negatively affected through silica dust. You know, we have codes of practices through each component of our company. And, you know, we do have internal silica dust awareness training, and this is internally built and highlights our specific control measures that's required within our locations. I would comment, and I think it's been said, you know, the awareness level in our industry has improved greatly. When I first started going to a frac site 10 years ago, you would see employees sitting on top of a sand trailer with all the hatches open, eating a sandwich, not for any operational purposes, just because of nobody was quite aware of the hazard of that. And I'm happy to say that those days are long gone now, and the awareness has increased dramatically. So I'll take you through our operations, and then talk about how we control silica dust at each of those components. So we are mining and production facilities. So during the mining, and you know, most people see frac sand at the well site. Not everybody's quite aware of the process and how we get it there. So we do have a mining and wash plant process. This is a shot of, on the top right there, of our one of our mining operations. At this point in the, for silica dust, at this point in the process, sand isn't, it is impure, it hasn't been refined quite yet, and it is damp, so the dust is limited. And also, this is a very limited exposure area for employees. It's mostly heavy equipment, and we ensure that our cab filters are adequate and monitored frequently. Like any mining operation, there is some road dust kicked up, but we do frequent road dust suppression through water application. And on the left here is a look at one of our wet plant operations in Preston, Wisconsin. So once the sand is mined, we put it in our whip piles, and it makes its way over to the dry plant. In the dry plant, we do dry it. This is a look at one of our large dryers. And then after it goes through the drying process, it goes to our Rotex machines that will sort the dried sand using screens. These machines will vibrate the product and then separate it into one of the 30-40, 30-50, or 100 mesh type product that we produce. So as you can imagine, as we go through the drying process, the sand is now dried, and dust is an issue, something that we look at to control. So over the years, we have moved away from a more administrative and PPE requirements and focused more on the engineering controls. So some things we've done over the years, as we've grown our facilities, we've had to ensure that our dust collecting system that removes the fugitive dust is adequate. And when we increase our production sizes, we've had in the past to increase both the dust collector systems and increase the number of pickup points that we've had within our facilities. We've also created a central vac type system. Obviously, shoveling sand is not ideal, so we've looked at trying to find ways to remove shoveling. We went from shoveling to using squeegees. We thought that was better, to using mechanical equipment inside our plants. But the best way to remove this is through dust collecting. So we've created this central vac type system now where we can vacuum up the sand instead of trying to disturb it manually. And we also have a mobile vac system so that if there's sand issues at other locations, we can take that and move it around as we need. A few other things we've added, here's a shot of our mobile vac system. We've added water where we could, usually in the waste system. There's a wet auger process at the end of our dryer where the waste product goes through we wet the sand so it cuts down the dust, and we use misters whenever it's possible. Using water is restrictive to the temperature. We've looked at in the winter time, we've had to reduce this because we find that it creates other hazards such as ice forming and muddy, slippery surfaces as well. So we use water when we feel it is safe to do so. We've also introduced dust hoppers anytime we've had bin style storage, or sorry, not bin, but tent style storage or open storage. You can see this hopper here creates like a laser beam of sand as it comes down, and it's quite surprising how much dust reduction happens when we use this dust hoppers system. And then the other thing in our production facilities, sometimes we bring in a third party and we wash down or completely wash down our facilities and kind of hit the reset button on any of the fugitive dust that has collected. So using this, again, we focus more on the engineering controls, and we've reduced the levels at our production facilities over the years. Apply a similar approach to our rail terminals. You can see here on the top right some of our tent and our dome style storage These are pretty restrictive areas. People do not work in there. In our tent, you'll have a heavy equipment operator in there. And other than that, there should not be people in there. Again, we focus on the heavy equipment filtration systems to make sure that they're adequate, and we do monitor our employees for dust. Down at the bottom here, you'll see a truck loading at one of our terminals. We've added automation whenever we can into our system. So in this case here, this is operated from the terminal office, and we do use cameras to monitor the sand. The truck driver will remain in his cab at all times. He'll move up, we'll load the truck remotely through automation, and then he'll move on. So, automation removing the people from those areas. Which brings us to the Sahara unit. So we've applied a lot of these engineering control ideas and added it into the design of the Sahara unit. And I'm going to run through a quick video here on how the Sahara operates and how it benefits for dust control. So it was like, so here we have a truck. All our Sahara units are belly dumped through gravity. They come over here. We can do up to, in Canada we use Super Bs, the double trailer. We can unload about 50 tons in about 10 minutes here. So you can see it's a short drop here. We've tried to find ways here to skirt in this area. We haven't found anything that's quite robust enough to withstand our oil and gas conditions at site. But this is one of the areas where we're working on for improvements. But the sand comes under here. It goes into our drive over belt. This is where we would have an employee right here working to unload the hoppers and then run the drive over belt. You can see the drive over belt is fully enclosed, so there's no sand dust being generated there, and then it feeds into our bucket elevator hopper right here. So this is an area that we've improved on. We have a sleeve that goes right into the hopper in this case, and it's also an area where we've added dust collecting, and this is one of the pickup points right in there. So it goes up to the bucket elevator, which is again fully enclosed. So no dust is generated there, and then into our shuttle. The shuttle is enclosed, and it goes onto a belt in there that can deliver it to one of the product to one of the 12 bins here. We can hold up to 4 million pounds into the 12 bins. This area does kick up some dust. The shuttle is enclosed. Not quite airtight, so this is an area where we added dust collection pickup points here as well. So with the dust collection, dust is at a minimum. Oh, let's go back. Okay, so this brings us to the main belt. The main belt is on the bottom of our bins. This area is fully enclosed. It doesn't show it in the animation here, but this area is fully enclosed, so no dust is escaping from here. It comes along our main belt on the bottom to our stinger. And again, the stinger, it's a very short drop. It is somewhat enclosed, but another area where we would include dust collection. So then it continues to our up through the stinger. You know, the stinger is adjustable. A lot of the blenders, as we've talked about in the last couple of days, they're very different designs. Some are bigger, smaller, higher, lower. So still an area. I would consider this a hot zone. We've made our stinger adjustable to accommodate for some of the different designs. Also, we have put dust collection in this area here to help cut down on the dust area. So we do control the sand flow from our doghouse, so we don't have any employees in this area here. They will monitor it through the doghouse here, and the doghouse itself does have positive air pressure. We've got a 2 filtration system in there with MERV 11 and 14 filters in there to keep dust down from entering in there. And that's a quick look at the Sahara unit and how we've implemented both enclosures, dust collecting, and managing the drop points throughout the system. So we do internal monitoring, and when I say internal, we work with a third-party industrial hygienist to do our own testing in and around the unit, and as well as on our employees. So we do work in Alberta, BC, and in Texas. So we're following these PELs. So in Alberta and BC, we're at these measurements are in milligrams per meter cube. I know I've seen it in micrograms. So we just move the decimal point 2 places on this. But using milligrams per meter cube, we were at 0.025 in Alberta and BC as our personal exposure levels. So I've summarized the last 3 sets of results that we've had with the Sahara unit. So these are generally the areas that we put our monitors. We've got an area monitor here at the drive over, and you can see that we are just below the Alberta BC requirements. We have a control panel where the person would operate the drive over belt, and again, they're below the requirements. Right here at the bucket elevator, we've seen improvements in that. That's a pretty small level there. And then out of our stingers, one of our higher zones, again, I think that would be the hot zone in the system. Then within our doghouse, with the positive air pressure and the filtration system, the numbers are quite small. And then we do area samples downwind of the Sahara, and we've had no measurable silica dust measurements. And then our operators are just above the PEL levels for Alberta and BC at 0.030 milligrams per meter cube, but again, below the OSHA requirements there. It is a little higher than the general area, keeping in mind that the employees are moving in and around these areas, and there is some concern that there's dust collecting on their coveralls, which is something that we're addressing as well. So as we continue to improve, and we're getting close to having an area that is completely below the Alberta BC levels, we continue to improve, and with the hope of one day our engineering controls can remove the requirements for PPE at the site. Right now we're using half-face respirators just because we're walking the line on exposure levels. But as we continue to improve on this, we're looking at, we have decontamination boots. Right here, you can see our employee using one of those. We're looking at ways to continue to improve the drive over. And also, you've heard it, the blender drop. You can see a picture here. Currently there's some tarps and whatnot being used. You can see our dust collecting system sucking the dust right at that source. Still an area for improvement, working with the various sizes and designs of blenders. And that concludes the presentation, and willing to take some questions or comments.
Great, thank you, Sean. Great presentation. Couple of comments and or questions. Something similar, I guess, to something that had been brought up in a previous kind of silo presentation. Any wind stabilization issues, in some of the areas that you're working with related to your equipment?
Yeah, no, our equipment is fully engineered. It is rated to 120 miles an hour for wind resistance. So, and working in the Alberta winters, it's withstood some serious weather.
Yeah, understandably. You mentioned several what appeared to be maybe average values, for the different job titles that you had mentioned in looking at potential exposures. How large of a data set is that, if you don't mind me asking? I mean, is that collected over the course of the past 5 years? Are those your most recent, site visits? Just how much data do those averages represent? And just to give a little bit of confidence in how much those values represent.
Yeah, so those values were summarized from our last 3 sets of data sets using three different Sahara units. And again, as we add our engineering controls, some of these things have really been going down. But yeah, this is averaged over the last three surveys that we've been doing.
Okay, great. There was a question from the audience. In addition to engineered controls, are area monitors also used permanently in risk areas? Kind of, again, a question related to exposure assessment.
Yeah, no, we do not have constant monitoring systems there. We do, multiple surveys quite frequently, but not anything that's constant. No.
Okay. I don't see any additional questions that have come in. I don't know if you had any last comments or anything before we move on to our next presentation, which we're right about time for. Any other questions? Okay, I don't see anything coming through. So, Sean, thank you very much. We appreciate your participating today, and great information. And again, great to hear about the successes that you've had in reducing those types of exposures for workers in and around these areas. So, thank you very much. And we'll move on to our next presenter. Actually, pardon me. We actually have a break now. So we have about a 5-minute break. I'm going to share my screen really quickly. And then I will. Again, same message from yesterday during our second break, that if anybody, in the audience has an interest and willingness to discuss your company's efforts at evaluating the effectiveness of the controls that we've either seen today or that you might be using at your facilities and your sites, please let us know. We're very interested in talking further. So give us a shout out at the emails that I've put on the screen. We will be back in about 5 minutes at 12:45 Mountain Time, 2:45 Eastern, and then we'll get started with our last session of the day. Thank you very much.
Bradley, it's Kaylee. Do you mind if I try sharing my screen?
Not at all. Hey, Kaylee. Let me stop sharing and then you can try. Okay, I've stopped, so that should open it up for you. Okay, I see your slide. It looks great. No issues.
Okay, great.
Would you like to keep this up through the break? And that way you just have it up.
Whatever you'd prefer. Yeah, whatever you prefer.
Actually, why don't you go ahead and stop sharing, and I'll share, because I do usually like to put up the agenda for, kind of the next section. So, but it looks like you should be able to share without any problem.
Okay, thanks.
You hear me okay, Kaylee?
Yeah, that's perfect, Ian.
Hi, Ian.
Hi, Bradley. Nice to meet you.
Nice to meet you as well.
So used to Teams, I gotta get used to Zoom.
I know.
Hey guys,
Hello, Anna. How are you?
doing good, doing
Great.
good. How are you?
Great to see you again. Thank you. We'll be starting up in about 3 minutes. We'll get started with Kaylee and Ian's presentation, and then we'll move to the panel discussion. So I see James as well has been promoted. So we'll get to you guys, after this section. All right, everybody. I have 12:45 on my clock right now. Let us talk about what it is that we're going to be tackling in our next session and final session of our Silica in the Summit 2.0. So we will have one more presentation from some colleagues of ours from Ovintiv, Kaylee Boot and Ian Wilson, who will be discussing kind of their journey at Ovintiv and some of the controls and technologies that they have used, have tried, and are moving forward with. And then we will close our event today with a panel discussion with a couple of our industry colleagues, Anna Ohmsberg from Ovintiv and James Coleman from Pioneer Natural Resources. We'll have a moderator, Kyle Kruger, who will be discussing them, kind of having a conversation specifically about some of their thoughts, lessons learned. There will be an opportunity continuing to have some questions and answers brought up, but hopefully that'll be a really great discussion, more of a conversation rather than a presentation. And so we're looking forward to that. So our first speakers up before we get to that are Kaylee Boot and Ian Wilson. So Kaylee and Ian, I'm going to stop sharing now. And that should open it up for, I think, Kaylee to share her own presentation. Okay, great. I can see that. Okay, so let me go ahead and do an introduction real quick. Kaylee Boot holds a Master's of Science in Occupational and Environmental Health from the University of British Columbia. She has 10 years of oil and gas experience and has held her CIH for 5 years. Kaylee is the Senior Industrial Hygienist for all of Ovintiv's North American plays. Of the hazards in oil and gas, she has spent the most field time focusing on silica. And then co-presenting with her will be Ian Wilson. Ian Wilson is a manager of commodities and logistics at Ovintiv, formerly in Canacorp. Before joining the company in 2014, he spent 6 years at Schlumberger in a variety of roles in drilling and completion segments. He has a BS in civil engineering from Colorado State University and an ME in petroleum engineering from Texas A&M University. So Kaylee and Ian, the floor is yours.
Thanks, Bradley. Right, so as he mentioned, we're going to be sharing our wet sand results. We're going to go at it from 2 different perspectives, an industrial hygiene or exposure perspective, and then Ian's here from supply chain, as Bradley mentioned, to kind of offer the logistics side of each control we've tried, and wet sand especially. So we'll go over our exposure limits by the plays that we're in, silica as a commodity itself, and then some of our existing or historic controls we've tried and how they've worked, and then into our wet sand, why wet sand, the data, and where we're headed.
Thanks, Kaylee. Now, as a multi-basin operator, we get to see, a large range of different regulatory jurisdictions, different climates, and different vendor bases. And as you can see from our ever-changing asset map there on the right, we operate everywhere from British Columbia and Alberta down through South Texas. And then historically, a lot more places than you actually see here. We've tried different systems and solutions, through time as well. And with that, being able to kind of sample, I guess, what we think is maybe the best from different vendors and different areas and different climates, we've really been able to kind of hone in on what works and what doesn't, and what kind of environments we need to focus on.
And so to add to that, with the different exposure limits and being controlling employer and prime contractor, we've sampled all the workers on our site. We haven't hesitated to ask our service providers if we can sample them and get a real transparent indication of how our controls are working. And some of this has been because of our shift to owning the sand a bit more. And Ian, I'll talk more to that.
Yeah, taking a quick step back, we just want to kind of highlight of what is our perspective of the sand supply chain, and what do we focus on. If you look at the bottom left pie chart there, as our wells get, let's say, as our reserves and our reservoirs get tighter and tighter, our fracturing treatments get larger and larger. And so we've been using more and more sand in our wells over the years, and so that fracturing component keeps growing year after year after year, and so it really required us to start taking a hard look at what the components within that fracturing train or chain instead of just relying on an integrated service provider. And when you break up what's inside a frac, you'll see that proppant, is almost half of our spend. And when you look at proppant, obviously, you have the mining phase, but then, when you look at the traditional sand supply chain, about 70% of it is of the costs come in logistical costs. So you see a lot of the evolutions that the industry has made has been an attempt to make that more efficient. And we'll kind of see that in some of the solutions that we've tried over the years.
So I know we've learned a lot over the last few days about silica, and I'm sure most people in this room have such a great appreciation for it. I know I've learned a lot from some of the different images that people have used. I think yesterday the mining picture of the, I think it was the Rose Bowl Stadium, that was really meaningful for me and new for me to see that context. This is just some of the information for hazard communication we've used that we've found really meaningful to our audience, especially when you compare it to lead dust and non-toxic dust. People can really start to appreciate how this isn't just normal dust you see at the sand. So we've just included this here because anyway, we find it pretty meaningful, and some pictures from Erect there at the bottom from NIOSH. So in terms of the different controls that we've trialed, we've attempted to bucket them differently here. I know that could be up for debate, and it's definitely a fluid spectrum sometimes, but yeah, in our substitution bucket, ceramic, coated, and the wet sand. Engineering, we've even tried flock tanks where we've used water to help just deal with the displaced air from pneumatic inloading. Bag filters like we saw with NIOSH and mechanical ventilation, and then handling systems that we've talked about a lot already. Other approaches we've tried: misting, the silos, site arrangement, and best practices. This became more important when we started implementing engineering controls, because those best practices really have a impact on how well the control works, especially with ventilation. So with each control we've implemented, what's come with it is quite a bit of work. And so we have a data set of about 300 data points, just over 300. And it's been our best attempt to quantify every different permutation of control that's been introduced to our site. So whether it's pneumatic, gravitational, horizontal, box storage, or vertical, you can see how quickly the permutations of what comes to site need to be quantified. And the whole point there is to communicate the residual risk. So does this setup, reflect a need for what type of respiratory protection, and hopefully none at all. And then the fourth phase there is our field verification to ensure that that message has been heard through the chain of command and verify that that's implemented on site. And we have a few tools to do that. So in some of the data that we're sharing here today, I did mention we have 300 data points. By the time you narrow it down to the type of arrangement on site and prevailing job title or task, a lot of the data I'll share is about 5 to 15 different singular data points. And so we've defaulted to wanting to tell kind of the worst case scenario, and I realize that's not in some of our control's best interest. It's not telling the huge success stories, but it's telling us as an industrial hygienist what we have to recommend for engineering control or for respiratory controls after the engineering controls have been implemented. And within that, I just would say that a lot of our data points have been collected circa 2013, so they're dated. However, as we kind of inferred in the last image, it takes quite a bit of time to get down to site with the new controls and to quantify it sufficiently across our plays. And so this is what we've had to make our decisions based off of, but it's definitely not how well the equipment is performing today. So in terms of our ventilation controls, we saw a huge reduction, and that shouldn't be underestimated. In the case of ventilation, there were quite a few different best practices we implemented, such as kind of the 45-degree angle you see here, trying to get some non-corrugated material between on the flex hosing. However, it does need to be fit for whatever equipment we have on site. And then working with the ventilation companies to ensure blast gates were implemented where we could to reduce the volume of suction from the different sand chiefs on site. And so at the end of the day, did it work? Yeah, it definitely helped us get to a more reasonable place, especially for peripheral people on site. But at the end of the day, still required our hopper operator, represented here by the mean and the 95th percentile, still required them when we had ventilation to be using full face masks. In fact, this was over the protection factor of 50 when we're looking at the 95th percentile. And just a reminder, I know the 95th percentile and sometimes industrial hygienists, we go into statistics a little maybe too much, but at the end of the day, it's the decision point that we need to rely on to know that we can be 95% confident that the true mean of the exposure is going to be below that value. So, Ian, can you tell us a bit about how it works?
Yeah, and as Kaylee alluded to, one of the challenges with ventilation, especially with these systems, you can see with the vacuum systems, is they tend to be really fit for purpose. And so as we change out equipment or change out vendors, or even the vendors themselves have often merged with other companies, and they don't have standardized equipment that often anymore. And so sometimes it's really hard for us to get a good fit without a lot of extra fabrication or time or labor. And so that can become expensive, the labor intensive part, and the time to move the equipment and refit it can become challenging for our operations.
So one of the next controls we tried was sand coating. We saw a dramatic reduction, again, in comparison to ventilation, and certainly no controls for pneumatic and loading. And to a point where we got to a place of the 95th percentile being within a target range for no PPE. Our sample size is quite small for the hopper operator using sand coating. It's only about a group of 5 on different days, but I will say that it was quite impressive for the duration that we did use it.
Yeah, a challenge on the sand coating we found in the past is you have to set up some sort of facility to coat the sand at the sand plant or somewhere, usually somewhere centrally located. And as our operations move around, or we want to move closer and closer to our wellheads with the source, it's hard often to relocate, or very expensive to relocate that coating equipment. And again, it comes back to, it kind of reduces our flexibility a little bit on how we source our products. And then the coating itself, while the coating itself does add cost, if we add logistical costs, it really multiplies, I guess, the cost to our operation. Sometimes it makes it so it's not economical at all.
So as we kind of heard about from Sean earlier, we've since tried a silo system, which has been really impressive, considering it's not necessarily an added engineering control, but just a way of storing sand and inloading sand on site. So certainly by using the belly dump into the elevator that then pushes to the top, we've seen a remarkable improvement from pneumatic inloading, that's for sure. It had a 96% reduction from pneumatic inloading. Putting it on this chart would kind of dilute the other messages here, so we didn't include that. But yeah, certainly into going from ventilation into a silo system, we saw an 87% reduction in concentration on site. And that really got us to a place that instead of adding an added engineering control, we were able to take a situation where people were put in full face respirators to looking at half face respirators just due to this. So yeah, we're very excited about where the silo system's taking us generally.
And operationally, we've had great success with the silo systems. And as you've heard in this conference, they continue to make great strides towards more efficient equipment. We tend to use this equipment where we have larger load weights that are a bit farther from the sand source, because that gives us ample, I guess, buffer on location when we have that long logistical chain. So the silos are allowed us to really get a lot on location if something were to happen. And also it's a bit flexible on what type of equipment you unload into it. So it's been something we really lean on, and especially in the northern climates where sand usually comes from farther away.
So as we kind of go into wet sand storage and wet sand generally, you know, we have an interim stage with box storage that we're still widely using. And so box storage is interesting. These pictures kind of show the footprint that it takes on site and how it establishes a new zone and in fact a new job title. So the white box you can see here is where the hopper operator is positioned. And so that has created a lot more distance between you know, a hopper operator traditionally on the ground evaluating dust levels and remove them from that direct exposure. It's also created another job title of a forklift operator who moves the boxes on top of the conveyor belt. And so outside of wet sand, just looking at the box storage on its own, we have seen some really great data come back with this. And so just over our PEL here, we see a reduction from pneumatic unloading, and it's quite impressive. So our forklift, we don't have any hopper operator samples from this, and we're striving to get more from our area results. It looks like respiratory requirements are still required. And for our forklift operator, although it's a new job title, the benefit is that at least with the new job assigned to the location, we're not seeing an increase of exposure for that individual.
We find ourselves using boxes a lot, especially when we're really close, our operations are really close to the sand source. And one reason for that is that because we're not making a material transfer, we're actually moving the container off of a truck instead of transferring the material from one to another. We see we're able to move that asset off very quickly and keep the truck circulating. And when we're really close, that offload time often dominates our logistical costs. So we see a lot of benefits there with these boxes. Good thing from the silica dust perspective is that it reduces one transfer point. The truck doesn't transfer the material into another container because the container is simply moved. So you just see that main hazard point is in that hopper area, like we see with most systems. And the other good thing about the modular system is it allows us to kind of tailor the amount of area you can see in the floor, what we need. We can kind of change that around and kind of make different shapes with it. And we can also start moving from one location to another without taking down the whole system. And then, so now as we transition to the wet sand component, I know we've probably heard a little bit of it already today. So we thought we'd start first with why have we been using dry sand all this time in the first place? Well, you know, first of all, wet sand is difficult to handle. You can see it in the picture there that it sticks together, it sticks to other things. It's hard to transfer, it's hard to screen. So our specifications would have to be loosened if we weren't to dry it. And in addition to that, the traditional sand source has been Wisconsin, where the highest quality sand in North America sits. And so moving the sand from far distances to our location, you pay for that let's say 5% moisture, you pay for it, you know, all the way through to the wellhead logistically. And then on top of that, you see the source was in cold climates. So in the winter, that moisture can cause the sand to freeze together into a giant sand cube. Whole rail cars could be frozen and sand can be stranded. But if you think about how we've been moving the sand supply chain over the years, particularly let's say in Texas, if you look at that bottom chart, and it kind of shows our cost, just an example of different cost structures. So when you rail it in, you have a very large rail cost. You got rail cars, transload, kind of storage rail yard storage once you get into basin. And then you have to move that sand to your well site. And so over the years, you've seen move from premium to sometimes some regional sands that are not in basin, but closer. So you see a little bit step down in cost structure there. And then as you move to what we call like in basin sands, let's say within 100 miles, 150 miles of location, you remove that rail component completely because the trucking becomes more economical than the rail. And then as we keep pushing the envelope, if we get it in field, and then if you lower your operating costs by loosening those sand specs and not drying the sand and doing other things, you can see how drastic the end changes from the beginning of the premium northern white sand. And so when we first thought of this idea, we're not the only ones who thought of utilizing wet sand, but as the controlling operator, we were able to communicate kind of our vision to the multiple vendors that are needed to accomplish a big change. Just to give you kind of a scale, a lot of these huge mega plants that have been built, let's say in Texas, you can see that footprint on the top right. It's a really impressive build out, and it takes a lot of capital equipment and people to run that plant. And so while they're building this, along with some other mine tours, we noticed that they had these little mobile wet plants that are kind of building product for them while they're completing their mega plant. And we kind of started playing around with the idea of why can't we just try that, loosen our specifications a little bit, see if that's and see if we can make it work. And basically the problem with that is none of the equipment downstream of that, at the well side and in between was ready for wet sand. We had to make some modifications. So we went ahead and started putting our heads together with our different vendors and coming up with different solutions of how we could bypass some of the problems that occur when you don't dry the sand. And so we designed and built a prototype, and we tested it at different mines, from the feasibility to the prototype, and eventually we were comfortable enough and put it out on the well site. And since then, we've actually converted a good amount of our warm weather operations to wet sand. You can see one recent example is we are now washing sand in these pictures really close to our well sites in Permian Basin. And then last year we did something similar in the Anadarko Basin. So we're seeing the benefits of lower logistical costs, lower energy input into our wells by doing this. And I think Kaylee will share some of the silica dust data that we've gotten so far.
Thanks, Ian. So in terms of, you've seen the pictures now, in terms of what it gives us now, going from box storage where we saw the exposure for the hopper operator in the cab was still 10 times over the Pell. Once we've implemented the wet sand, we've seen a substantial reduction. I'll share that on the next slide, but we have a limited source of data. We have 18 data points, both area and job titles of blender, tender, and hopper operator. It is actually the same data set that you've seen in the PropX presentation. This is the benefit of, not only EHS working with supply chain, but supply chain working with our vendors to troubleshoot things. And so, yeah, we've had 3 different days, all similar pounds of sand being inloaded into the blender, all 100 mesh. So the variables that we've seen were pretty consistent, which is good. Just to ensure that our data is repeatable. But again, I just wanted to point out for the industrial hygienists, the hopper operators in a different location now, and the job does look different. So in theory, we would be calling this almost a different job title if we're looking at segs specifically. And here's a good picture of the forklift operator, just so you have a good sense of that role and the location of their exposure. So here's our data. Only 3 of the 18 data points were detectable. So just over the OSHA PEL at about 67 micrograms. And that was right in the hopper cab. So an area sample that was taken in the hopper cab. We believe this was due to the sand drying out a little bit, which is a problem with wet sand. He did have his door open, so really excited about the opportunities to control the cab from an air intake perspective. Like most cab operators, there's a tendency to keep the door open for communication and line of sight to the forklift operator. So we saw that as well. And then just to add some flair to these results, we saw a 29 microgram here from an area around the hopper and a 24 microgram for again around the area of the hopper. But generally speaking, those were the area samples, and all of the personal samples that we sampled for were non-detect. The blender tender, we had 3 on 3 different days, full shift, and same with the hopper operator. And we're not necessarily supposed to do statistics on data that's below a limit of detection. And so, popping it into the Bayesian software we have, no matter what the prior was that I set, so either uninformed or informed, the posterior was all looking well controlled. So I put that in for the industrial hygienists in the room. So it's very promising. I'm really excited about where this data is headed. And this is our last slide. So if we've lost anyone, come back. But generally speaking, here's our data that we represented today. Not seen here is ventilation and pneumatic and loading without any controls. These are all means just to bring a relative picture to it. And these are interpretations of non-detect data using a minimum detectable concentration. But you can just see the range that we're working with on our sites. We still have a combination of all of these, most of these except sand coating right now throughout Oventive. We're really excited to evaluate our cabs and try and figure out some filtration for in cabs. So I was really excited by the mine presentation from NIOSH yesterday. We're also looking to figure out housekeeping. So with our sand boxes and wet sand, we still see a lot of sand accumulating on the ground. And so of course, when that dries, it becomes an issue. And so that's something that we're challenged by. And yeah, that's pretty much all we have for our presentation. We're really excited about where we're headed with wet sand. And thanks for tuning in. Ian, anything to close?
No, we put our baby seal friend here in just because, this is sometimes how it feels on the operation while utilizing wet sand. I think you can ask Anna some questions in the panel, but it's definitely not the easy button, but we're excited about some of the benefits that we're seeing. So we'll continue to work and test and hopefully publish more data with our findings.
Great, thank you, Kaylee and Ian. Wonderful presentation and a great comparison of the variety of controls that you all have looked at and implemented and experimented with. So we very much appreciate your real world scenarios of implementing a variety of different controls and learning from your experience. We have had a few questions that have come in the Q&A box, so I'll start with those. The first is, does exposed wet sand, when in quantity, have to be covered during windy conditions?
So I'll start with on location. It is covered, so we'll always have so far, and we have them in these containers, and so the wind doesn't affect them at that point. Now at the mine, I'm not as qualified to speak to, but I know that it is pretty common at mines that they do pile up the sand to dry. But it seems to be that the moisture, it really only dries. It seems to only dry at the very outside of it, and it's pretty minimal dust from visually. But I wouldn't say that I've sampled that at the mine personally.
Yeah. Okay. Another question, given that natural sand leads to higher back production, quote unquote, of sand during post-frac flowback operations, do the cost savings of using natural sand during the frac operation validate the downstream equipment damage and used sand disposal costs?
So it definitely does. Because we pump so much sand on location compared to how much sand is actually flowed back up. It's definitely several orders of magnitude difference in the cost versus trying to bring in a more premium sand from a farther location. It's basically a volume game, and we utilize so much that it definitely overcomes the differences there.
Okay, great. Couple more just quick questions before we move on to the panel discussion. What type of exposures are associated with box filling, and what type of controls are in place?
So I assume this is at the mine as well. So it's filled very similar to true dried sand. So a truck drives under and it does fall into it. And as far as the exposures go, we haven't sampled them, but the wet sand is a lower. You definitely see lower free dust when you're loading with wet sand than you do with dry.
Okay, and then the last question is, in some countries, these processes are very important to obtain environmental licenses. Can your company advise or be part of helping to obtain these licenses?
I'm not sure which licenses they're referring to, Kaylee.
Yeah.
Bradley, do you know what licenses those are?
No, I don't. The question came from Mauricio Sarmiento. So, if necessary, we can get more information from him or reach out to him about that. So, unfortunately, that is about the amount of time we have for this presentation. We really appreciate Kaylee and Ian's time. And I think there was a comment that this presentation was a great example of how different delivery methods, equipment, and controls demonstrate different exposure data. So, I completely agree. And, I just want to thank you for providing an insight into your experiences there and you guys being willing to talk about that. So thank you very much. Okay, so our next and last session is not so much a presentation, but more of a panel discussion that will bring together a couple of experienced professionals to talk about their lessons learned, their challenges. We had originally had Kyle Kruger, who is a colleague of ours here in Denver, we had intended him to be the moderator. We don't see him online in terms of a listed attendee, unless, Kyle, you are on the phone. So Kyle, if you're there, can you hear me? Okay. Well, I don't hear him. So Kyle, if you are there, just let me know. If not, I'll go ahead and moderate in your stead. Okay. I don't hear anything. Okay, so let's just go ahead and move forward with the panel discussion. So I would like to introduce our two panelists, Anna and James. So if you guys could turn your videos on while I pull up your bios. So our first panel discussant is Anna Ohmsberg. Anna Ohmsberg is currently a senior completions engineer in supply chain with Ovintiv and has been in oil and gas for the past 15 years. She has 10 years of operational field experience in completions and is passionate about our health and safety. Anna has a BS in chemical engineering from Montana State University. And our second discussant will be James Coleman. Mr. Coleman is the HSE advisor with Pioneer Natural Resources in Irving, Texas. James is a certified safety professional with over 20 years of HSE experience, and his experience spans the construction, mining, and oil and gas industries. So welcome to you both. I see you both online, so I appreciate your willingness to come on and kind of have a conversation with us to let us learn about your experiences with dealing with silica exposures and controls that you've had at your respective organizations. And so, we had developed a series of questions that our planning committee had pulled together that we might think about talking through with some of you, but clearly, we're very much interested. I don't know if you both have had the opportunity to sit through the presentations that we've had both yesterday and today. But if you have, I'd love to hear your comments about any kind of themes or anything that jumped out at you in terms of some of the information that was presented, things that really struck you as being particularly important, things we can continue to need to think about as an industry. So I don't know if you had any opening thoughts about some of the things that you've heard before we get to some of those questions. James, would you like to start?
No, I have been able to attend almost every session, Brad. So it was encouraging to see a lot of folks that I've worked with on different projects over the past, and a lot of the products that I've used throughout my career in mining and then in oil and gas have been presented. So a lot of great ideas and a lot of advances in a relatively short period of time.
Yeah, absolutely. Anna, any thoughts?
Yeah, no, I have to echo that. So this is an excellent, conference. It's nice to see all the brainstorming and the innovation that comes from these things, right? I think when we cross-pollinate and we have these great conversations, it brings, it gets your brain thinking a little bit differently, right? So I'm excited to see where we go after this thing,
Mm-hmm. Absolutely. So, one of the things that I thought was really interesting in the last presentation was that it was kind of a combined presentation between the industrial hygienist, Kaylee, and the logistics and commodities person, Ian. And so I guess one of the questions was, oftentimes we can get siloed as an industrial hygienist or somebody in the environmental health and safety arena. Anna or James, how would you suggest an environmental health and safety professional kind of work more closely with supply chain or completions department, or even other departments within their respective organizations to kind of understand the budget restraints and logistics that are associated with silica control options, and really bringing a more cohesive approach rather than getting siloed? Any thoughts or lessons learned about kind of those types of coordinated approaches, not just from an industrial hygiene standpoint?
Oh, loaded question. No, so I'll tell you, I think step one is to try to identify like, where can we improve, right? Like, what are the challenges we need to overcome? And then, when you cross-pollinate between departments, it's amazing how each department thinks a little bit differently, right? So if you kind of put your finger on a challenge and talk to different departments and kind of brainstorm, it's amazing how you find like incremental savings. You find like processes you can tweak to help each other out. You find kind of ways to like work together and build and come up with creative, innovative solutions. What do you say, James?
I have to agree. I mean, from an HSE professional standpoint, 90% of our job, it seems, is about relationships. And any opportunity that we have to reach across the aisle, so to speak, and increase our business acumen, know our customers, internal and external, it's just an opportunity for continuous improvement.
Great, thank you guys. I just wanted to let you all know that, you know, our original moderator, Kyle Kruger, is actually here. I see him online, and he's a much better moderator than probably what I am. Kyle actually co-founded and hosts a podcast called Probability Matters, which is an amazing podcast focusing on issues impacting the health and safety industry. So he has these conversations with people within the industry regularly. He has over 15 years of experience in portable industrial hygiene instrumentation, and he resides here in Highlands Ranch, Colorado, with his wife and 2 young children. So Kyle, welcome to the conversation.
Yeah, no, I appreciate it. Yeah, with all those accolades, I still can't discern the time between Eastern and Mountain. So I sincerely apologize to everyone. Apparently, podcasting is my thing. Timekeeping isn't. Sincerely apologize for that mishap on my end.
That is okay. No apologies necessary. We just got started. We were kind of just discussing, as you may have heard, the kind of coordinated approaches, learning a little bit more about their experiences there. But I know we had had a conversation with all of us before, so I'll let you go ahead and get started in terms of kind of continuing the conversation.
Yeah, for sure. And I again appreciate everybody being on board. I think when we last spoke as a group, you know, the whole recap from our conversation was essentially, what have we talked about? We've got this looming essentially item that everybody knew was going to be coming to fruition, but now it's official. And so, you know, I was thinking initially, Anna and James, if there were maybe some commentary on items that were either you feel needed to be elaborated on, or just reflection on the panel to see where we've come in terms of how far we've come to make this the progress towards these silica standards, and maybe some of the items either that we need to continue to do, or maybe that we left off. So Anna, I'll pick on you because you're not muted to go first.
No, wait. Yeah. Okay. So I think so. If your question's around kind of what to focus on, right? And that, so I guess I'll take a step back. Like, that's where these conferences are so great, because, you know, as one company, we kind of focus on one thing, but then you come to these things and you kind of see what everyone else focuses on. So it broadens your horizon. I'll tell you, like, boots on the ground wise, right? That's where a lot of our focus and attention goes to, specifically. So in my world, it's frac sites. So a lot of interaction on location with the guys to kind of get feedback from them and see what their challenges are and what do they identify like as risks and hazards, and, you know, reaching out to the right people too, to kind of address the issues those guys see, to drive efficiencies and safety, and just to get, you know, there's so many people on a frac job that there's so many different mindsets, and everyone kind of, it goes back to everyone thinks a little bit differently, right? So things are, and a lot of times those guys on location have solutions that, you know, if we're sitting in an office somewhere, we don't realize. So I'm huge on those kind of conversations and see a lot of value add from that perspective.
James, one thing I found was really interesting is what you bring to the table in terms of your, as we were talking a couple weeks ago, is that this isn't your, to use a very Texas term, this isn't your first rodeo in terms of dealing with silica, as you've had a lot of experience in mining and other applications. And I think we all sort of agreed on that last point that people don't talk enough with the field. A lot of these decisions are made in offices, in corporate environments, but they're not being made where silica dust is present. So I'm just curious, James, from your perspective, what some approaches have worked to maybe take a check of, okay, we're about to deploy this whole system to be in compliance. What do people need to be aware of as they make sure that, you know, to have a piece of documentation is easy, but to make sure it's actually being implemented and that it actually works. So could you maybe reflect and share upon some of the practices you've learned over the years?
So I made just a couple of general notes while Anna was talking there. and really related back to what I've seen over the last 2 afternoons. So the first thing to continue doing, back to your original question, and what I was really encouraged to see the last couple of days, is to learn from other industries. So I started work for Pioneer in 2012, and one of the very first things I did was go to Houston to a STEPS meeting in regards to silica. And very shortly thereafter was to go to the field to a frac fleet. At that time, we had our own fleets. But as I said in that meeting in Houston, and as I went to the field and then continuing through that process, partnering with our pumping services group and working with them, was to learn from other industries. And we've heard a lot over the last 2 afternoons about what's worked in mining. I think somebody mentioned here this afternoon, I think, about, looking at cabs and some of the things that I've been able to do in the past. If you look at a blender cab, or I think Solaris had mentioned one of their dog houses, or I know the data vans that we've had on different fleets have. So the application, that positive pressure and enclosed cab, I remember putting one in for our crusher operator, and basically got down to where he had a positive pressure enclosed cab. He had controls. I think the gentleman from Solaris talked about integration, where we didn't even have to use respiratory protection for him anymore. Those were outstanding. To Anna's point, talking to the field, the people that are actually out on location doing the work, you cannot put enough stress on the importance of that. The very first time I went to a fleet, and one of the questions earlier kind of addresses this. The very first time I went and talked to a frac fleet about silica and respiratory protection, you had your typical, safety meeting, tailgate, so to speak. But after the formal part was over, I felt like I was getting chased by a covey of quail almost. I had, people asking questions, and a lot of times we think we know, but if we don't talk to the people that are actually exposed to these hazards, we don't know until we actually know. And we're only going to find that out through communicating with those people. And then the last point and I heard this, I believe it was yesterday, regardless of what direction anyone goes, we've heard a lot of great solutions over the last couple of days. But I did hear it yesterday afternoon about preventive maintenance, and cannot stress that enough, because we can put all the time, the ingenuity, the investment, but if we don't take care of those things, they're not going to work properly.
Absolutely. And Kaylee, I think Kaylee's on. I wanted to sort of call Kaylee out if she's able to be unmuted, which is you bring a unique perspective to the table in the sense that, you've been on the IH side trying to explain this mystical dust that if you breathe in today, it's not going to be a problem, big deal, but it may be a problem in 20, 30 years. Can you maybe share a little bit of and I don't want to get too tactical, but a little bit of maybe some of those breakthrough conversations that you've been able to have with people on the ground where you've started to get momentum? Because, even though you've got a solution in place, a policy in place, it doesn't always mean that it's being followed. So can you share and maybe elaborate on James's point as far as that maintenance of checking back in some things that have worked for you?
Yeah, certainly. Honestly, I know maybe I'm just not a great hazard communicator, but in the slides that I presented, the lead one really drives people home. I think as a culture, we generally have a great appreciation for lead, and not just lead for ourselves, but it reminds us of our children, and so having those conversations around the lead comparison have really driven it home for some people on site. I would say most operators on site have been very receptive, but where I was kind of going with this is like my most successful messaging on site has been when I've showed up with one of our senior managers from the office, and they've seen them, they're used to seeing me. They're not used to seeing that senior manager get to site and have the pause. Like if I'm harassing them to put a pump on them and I'm trying to like secretly tell them my message of hazard communication, they're like, yeah, I get it. This is what you do. You're passionate about it. But when the senior managers come out and they're stopping their day, because we know they're really busy, and they're doing almost like a safety stand down, we call it at our organization. And sometimes those are too frequent, but like that and them having one-on-one conversations with someone like a hopper operator who is at kind of the, as far as I'm aware, the bottom of the hierarchy for when you first get to a frac, and then you graduate up to some of the different roles, like maybe into a data van. I would just say, I think that having the senior management there with you has been like some of my most successful times.
And so would you, if you had it, and I know those senior managers are tough to have, I mean, are you suggesting that maybe that's a specific highlight of a meeting? I mean, how frequently are we touching on that? I mean, everybody likes to cut the ribbon and hold the scissors, right? Because that's the fun part. But I mean, what do you say in terms of being able to continue to bring that point home past, when the ribbon's cut and it's 6 months down the road or a year later, or maybe 2 years later, to speak about the efficacy of the programs and where areas need to improve?
Like I think today's an interesting example, right? Like a lot of the scientists are here around the table today discussing this, but I doubt too many hopper operators are able to tune in, right? And so I know that our data is dated, but like telling people at the end of the day, hey, I know this engineer's in place, but if you don't choke feed the hopper and not have a drop distance, or if you can reduce your drop distance, I'm going to be able to take you from a full phase to a half, or with wet sand, if we really focus on this part, we can take you down to no respiratory protection, hopefully. And so I think just making it meaningful to them in terms of what they have to wear all day, certainly with COVID, we're all more aware, and so is our management, of what wearing a mask feels like, and not putting people in respiratory protection all day. And so I think that that's going to be a big win, just in terms of our in-office communication of what some engineering controls still have to have in place when it comes to respiratory protection.
And James, I've got to, and Kaylee, I appreciate that. And I want to sort of call the veteran who has worked on continual improvement, right, in these sites, wherein in a mining application, you may have a silica program that has worked for you for years 2, 3, and 4, but maybe over a period of time, either that starts to wane, or we need to come up with creative ways for improvement. Can you speak to some of your successes in continually maintaining that program and then making sure you're staying into that constant improvement where the program doesn't just sort of stay static for a period of time?
That's a loaded question again. That's a long answer too.
Yeah, I'm known for that, so I apologize.
But I think really you kind of answered that question. It's just being in a mindset of continual improvement. And I think that the innovations, and if you look at the oil and gases, particularly frac, and how far we've come, all different aspects, not just health and safety or silica, but since 2007, 2008, that time frame of that downturn, and how we've always improved, whether it's production minded or cost basis. It's just, I can't sum it up any better than just that mindset of continual improvement. I think it's every aspect of the job.
And Anna, from your perspective, from the completions engineering side and some of the supply chain side, I know a lot of people talk about a policy, a lot of people talk about the communication, but when it comes to the nuts and bolts of making sure that your supply chain is ready and your operating unit is ready for this, can you kind of speak to some successes that you've had in working with that type of supply chain mentality that maybe some other people don't know? To Kaylee's point, I don't know how many supply chain folks or even procurement folks are on the line to understand the impact of all this.
Yeah. So I think it starts with kind of studying the process, right? So what are you trying to improve? Like in our case, we're geared towards pivoting from using dry sand to wet sand. So which helps our silica exposure limits, right? So study the process. What all does it take? What do they do to make dry sand? Can you change your process, instead to just simplify it? But there's a lot of so to your point, Kyle, there's a lot of, it's not an overnight lever, right? So there's a lot of studying and thinking outside the box. And, oil and gas, we kind of get stuck in this oh gosh, like this mindset, because we've been fracking basically the same way for, I don't know, 50, 60 years, let's pretend. To James's point, a lot of things have evolved since 2007. I mean, even in the last 5 years, things are always evolving, right? And so you kind of are looking at your processes. Do we necessarily need all those steps? Do we need more steps? Do we have the proper equipment that it takes, in my case, right, to take it from the mine to pumping it down hole? Studying each piece of equipment that sand touches, and kind of changing those processes to adapt to, help us with in my case, our changes from dry sand to wet sand, right? And not just that, right? So I come from one company, but it takes, so sitting in an office, of course, we have great ideas on paper, right? But it takes the guys on location. Those guys have excellent ideas, but also reaching out to your partnerships with your vendors and with making sure everyone's aligned, because you touch so many different pieces of the business you got to set yourself up for success. Otherwise, everyone's cussing your name. So.
Yeah, name cussing is certainly not a fun byproduct of all of this. And I don't always associate name cussing and contractors, but that has happened in my experience. And Kaylee, I'm curious from your perspective, from looking at the corporate side, setting policy. Once, let's say you've got internal supply chains going on, these are all things under your control, but now you open up to an outside contractor that may be going to your site where you've got your specific policies and certain specific supply chains. You're using wet sand here, they're using dry sand here. How have you gone about tackling could be somewhat of the behemoth of communicating why your standard is important when they may be getting a different lecture from a different industrial hygienist in the next job? How do you find that balance to help communicate that? Because sometimes the highest exposure may not be to your people, it may be to their people.
Yeah, I think that's a good point. I mean, I do believe in our company, we have a very strong culture on controlling employer prime contractor, as it's referred to in Canada. And that's been a big driver and thing we can lean on always. But I mean, one of my learnings through this experience, and maybe Ian and Anna can chime in, but has been, I know this sounds kind of boring, but the contracts phase can be underestimated. And so if you can get into the contracts phase and have that really well communicated in terms of your expectations, that seemed to just set the ball for us. I would marry that with, since that's supply chain, I would marry that with our ISN tool that we use that manages service providers, ensuring that we're holding that service company accountable to surveying and making sure that service providers are submitting the right documents. And what that comes down to is defining what the work is going to look like and the risks. And so oftentimes in industrial hygiene, I think whether you're exposed to benzene, norm, or silica, that can be overlooked in a tool that manages your service providers, because it isn't safety and it's not acute risk all the time, right? And so anyway, I found that those two areas, contracts and service provider software, is really where you can at least get a head start on that.
So, and I think you bring up an interesting point in terms of where that's at. Are you implying that you need to have a relationship with the procurement people to know it's a line item to bring it up, or how do you make sure that that's inserted? Because clearly they're talking about some serious dollars and some serious costs, and contractors are basing their job rates based on what they think their bill of materials are. So how does one get in there? Because I'm sure I can't see everybody, but if you were to raise your hands in terms of like IH Silica folks, how many people are involved in the bid process? I'm guessing it's a relatively low number of hands, maybe a pinky or two up. So I'm just curious, what do you find is, or maybe some open questions for the group, if they've been successful in being able to be part of those early conversations?
Yeah, I don't know. Anna, do you have a recommendation? I mean, with us, it's kind of come about organically. I would say silica, of all the hazards we've faced, has been the one that's driven our progress in terms of our relationship with supply chain the furthest. And so that's really helped. I know something that's becoming more and more important is data ownership. And so we've actually just gone through legal, because EHS has a legal rep, and so does supply chain, and they're on the same team in legal and in contracts. And so we've communicated to ours, who have then communicated to supply chains to say, if someone comes to site with impressive technology, we want to be able to play with that data. We want to own part of that data. So if we're paying for a service, and I guess an example could be like the Sahara unit, right? We saw some really impressive technology there in that presentation today. And so could we potentially build it into our contract to not necessarily own the how the data is used, but to have insight into that data and share data. I know that's been something we're working on with a lot of our EHS vendors now in contracts. But any other better answers, Ian? I'll call you in too, Ian, or James or Anna.
Yeah, Ian, chime in. Yeah, so, James talked about how relationship piece is important, right? So a lot of times when you're talking to like vendors and they know that there's a challenge you're trying to knock out, they've already, a lot of times they're ahead of the game and they have a lot of solutions, right? So, and that ties into like the MSA portion that Kaylee's talking about, right? And kind of putting some of the ideas on paper to make sure that we execute accordingly, right? So, so I'll, if people know what your challenges are, a lot of people line up to help you, and there's a lot of solutions out there too, right?
And I guess, James, my question would be to build upon that, about the relationships or whatnot, is that many people, when maybe you're at that conversation, that supply chain meeting, you're now proposing new costs, right? So now we've got to either invest to save ourselves from something in the future or change out certain items. And James, I'm curious, from your veteran perspective, what are some of the best tactics or practices that you've seen for people who are having to make the pitch or the position of being able to make these changes for that business case? Because a lot of people are going to they're going to receive pushback from people who don't have a full understanding of the program, and they're just looking at it going, well, there goes our profit. So how have you found the best way to be able to communicate with those people when they're not even in the bid process, but maybe they're getting pushback in that bid process for even inserting that language?
I was really hoping you'd forgotten about that question, Kyle.
I don't.
I know, but it's a great question, and it's really one that's tough to answer. I mean, because there's no two people or no two relationships that are exactly the same. I mean, I've presented the case by, with cost analysis. I've used personal experience stories. I mean, it really kind of just depends on the person. That's been my experience anyway. And if you don't know your business partner, if you don't have that relationship established, it's kind of hard to know which one of those tools to pull out of the toolbox, for lack of a better explanation. So I think that you have to be ready to explain it whichever direction, whichever way you need to go. You're going to be dealing with those business partners that are going to be a lot about data. So, to have data like that Kaylee had there is going to be detrimental. You're going to have it. You're going to have those people that are going to rely more on, life experiences and what they've been dealing with or what you have been dealing with, that you can give actual examples. I've used both. And then you're also going to have the folks that are going to be about the bottom line. How's it going to affect my margin? So we as a health and safety professional, you really have to be ready to go into those conversations. And those are the three main avenues I've used in the past, and you better be for all three of them.
Absolutely. And to sort of dovetail out of a common theme of what we talk about on our podcast is we're constantly getting back. It's like you can time it at like 32 minutes of every episode. It's like, why don't we all get together and talk more? So I think but that's a serious challenge. And I know that sounds very much like kumbaya and graham crackers and apple juice, but it really is something that does reiterate and make sense. And I think for the health and safety professional 2.0, and I say this having interviewed over 50 professionals in this field over the last year, is to get a pulse of that. Things are changing and becoming far more interoperable. And so the more relationships you can have with even somebody from a data science background, or somebody from an operations background, somebody from a supply chain background, being part of those meetings is absolutely crucial to be advocating for. I know we're all relatively biased, those that are in the health and safety or IH field, to understand why we do this in the first place is to help people. I mean, to get throughput and to get profit is great, but we have a really noble mission to be advocates for. But we often find that some of the stumbles that a lot of our guests talk about are the fact that they just have a struggle making it relatable to that. And on top of the fact that you're constantly talking about this nefarious thing that nobody can quite see right there. They may not know somebody who's been affected by silicosis. They may have heard the stories, but they can't point to James or to Jennifer or anybody in their company that's been able to have it. So I would say to sort of add to that point that yes, that's a common thing that we're seeing, and the only solution isn't here's the playbook, right? Is all right. Here's the main thing is you're a human. Go talk to another human in another department that has another understanding and get to know what their business is. And I think that's really an important part. Bradley, I know we've got about 7 minutes. Do I have that right? As you know, time is not my forte today, so I can be completely off with that. But as we're going toward the end here, what are some other points that you think either the panel discussion hasn't hit on, or items that we want to maybe have as a closing out of the conference?
Yeah, no, thank you very much. I appreciate that. There was another question I think someone had brought up specifically, and I think we kind of talked a little bit about it, but I kind of would like to get some more thoughts on any successful approaches, clearly training of workers in regards to silica exposures and the hazards that are associated with that is hugely important, and requirements. Have there been any particular successful approaches to silica hazard training that our panelists have implemented or have seen that they've really found to be very fruitful, that might be useful for others listening in, that particularly resonate with the oil field workers themselves?
I think anything visual, to the point Kyle made a few minutes ago, we're talking about traditionally a chronic disease, something that somebody can't see. I've seen the quarter used, the dime. I've used examples in the past where actually use an example of using like an artificial sweetener and dividing it up and really giving those guys something visual where we actually take out a tape measure and give them an approximate cubic meter of air and just dump this little bit of powder in it, and the light bulbs come on, the eyes get big. I think Kaylee mentioned it in her presentation earlier about the picture of the Rose Bowl. Those are all great things that I think anything that an average person can relate to, that they can actually see and kind of go, oh wow, this is what they've been talking about, really. So
yeah, and not just to understand like what exactly it is, right, but also to make them understand it's not just about them, it's about their family. That's, you know, so a lot of people don't like we're selfless and we, you know, we're macho, whatever, but if you're your brother's keeper, or if you make it relatable so that you know, your kids are gonna worry about you in 20 years, you know, your neighbor down next door that's got respiratory problems, you know, maybe he's someone elderly, or watching him struggle, you know, your kids don't want you in that situation. And so a lot of times they'll take a lot more serious when it's more about their family and their friends, and, you know, because everyone wants to help each other, right? So I think that's another way to relate and try to get it to sink in, right?
I would build on build on that more. Andy Sakela he presented the clothes cleaning booth yesterday in his presentation, and Adele Abrams had asked a question about, you know, MSHA, OSHA, and I still remember when I actually wrote to MSHA and got the variants and did all those things to install that piece of equipment. And it kind of goes back, Kyle, to, you know, being able to talk to people, and because it was a cost, it was still relatively new then. And to Anna's point, that was the point that I made was, hey, these guys are in it all day long. What do you think it is when they go get in their car and then they pick up their kids and they take them to Little League practice, and, you know, they've got cloth seats and they sit down and the dust comes up, and that I truly believe that was the determining factor, was making it personal for them to justify that expenditure.
Those are all wonderful points. And the thing I'll also reiterate is we're in this era of, I don't know, we're probably in a couple, I mean, I don't know how many different states and certainly a couple of different countries. We all have the ability to connect with one another. We all have certain mediums. I know like social media for health and safety is crazy different than most social media, but I would advocate that if you have a successful story or an example that can be shared, why not share it? Because that could be an impact to somebody else. We all have that opportunity. Everybody's been connected. Keeping that conversation and that sense of community going is vitally important. And that's one thing that we continue to see on our side of things is continue to make those connections and tell those stories. That's when we win for the case for worker health, is when those personal stories are shared. When we lose is when accidents or things happen. Well, everybody circles together, doesn't share knowledge, and we just really miss out on a lot of opportunities. So no, I thought those are really, really good points that everybody made there.
I completely agree. And I also want to put in a plug for NIOSH as well, in terms of, you know, you both have spoken about kind of making it personal, you know, really emphasizing how this can impact the worker, their family, you know, their friends, their coworkers. If there's any role that NIOSH can play in the development of communication products that highlight some of those personal stories, some of those really ways to, you know, drive some of this information home, I invite not only the panelists, but anybody listening in, you know, as the attendees to work with us. And we're more than happy to try to develop some communication products that help to address this issue, that could potentially be used in training opportunities, that would be supportive of your efforts there in your industrial hygiene and environmental health and safety effort. So I just want to reiterate to please think of us as a resource that you all can use in that type of effort. And you know, we would welcome the collaboration on those types of things. It is 2 o'clock now, so I don't want to hold anybody over time. I just wanted to thank all of our panelists today, including Kyle, and for helping to have a really great conversation. I hope that this has provided some new insights, pardon me, as to what some of our leaders in the industry are doing and thinking. I do want to share my screen one last time, which will, let me see if I can pull this up real quick. Whoops. At the end of the day today, we will be asking for you all to fill out an evaluation soon. There's a couple ways that you can fill this out. If you want to stick around and stay in the Zoom meeting, Courtney Cuff will activate the evaluation form and you can actually fill it out now. But we'll also be sending a link out to everybody or an email to everybody. And within that email, there will be a link to that evaluation. We would love to hear feedback as to what you thought went well, what could we have done better, and also any ideas for future events that we think would be helpful for the industry to highlight issues not only related to silica, but for other worker exposures in the industry. So please be cognizant of that evaluation and that we'd love that information. And I just wanted to thank all of the panelists, all the participants in our past 2 days for your attendance and participation. So Courtney, I guess I think I'll leave it up to you now to activate the evaluation form.